known scientist in the field of flexible photovoltaic material. So now I asked Dr. Pankaj, he will start his talk. Okay.
Thank you, Dr. Bhanu, for the introduction. Good morning, everybody. Am I audible? आवाज आ रही है ना? Hello. Hello. Am I audible now? Yes, it's better. Thank you. So, good morning, everybody. My name is Dr. Pankaj Kumar, and I'm principal scientist from the Advanced Materials and Devices Metrology Division of CSIR-NPL. I'm going to tell you about a very futuristic and fascinating technology which we are developing here at NPL. Actually, we are developing the solar cells which you can print on any substrate you want. The rigid substrate, you can print them on the glass substrates, you can print them on plastic, you can print them on fabrics, you can print them on metal sheets to make them flexible. So, we are developing that technology over here, and in the coming slides, I'll be showing you what we have been doing and what we want to do in the future in that area. Okay, I think I didn't know to tell you about the solar cells. Solar cell is quite common technology known to everybody. That is the technology which converts solar energy into electricity, and using that electricity we can fulfill our energy needs. But there is not only one perovskite solar cell technology, there are a number of solar cell technologies, and the name of the technology is given by the material which we use for that particular solar cell. Suppose the active material which absorbs the light and it converts into the photons, light into electricity, silicon. So that solar cell is called silicon solar cell. Similarly, if the light absorbing material is an organic semiconductor, that solar cell will be called the organic solar cell. But here in the perovskites, we are using the perovskite semiconductors. So basically, the perovskite solar cells are made of the perovskite semiconductors. So the perovskites, what's basically the perovskite? Perovskites are not new materials. They were discovered in 1839, but nobody thought of using them in the solar cells actually until 2009. Perovskite, actually in 1839, a Russian discovered the calcium titanate, and he named that calcium titanate as a perovskite material after the L.A. Perovsky. After that, all the materials having calcium titanate crystal structure and having ABX3 formula, they are called perovskites. All materials having ABX3 formula and the crystal like the calcium titanate are called the perovskites. So basically, in perovskite solar cells, we use the perovskite semiconductors, and basically the perovskite semiconductors which we use for the solar cells are the synthetic perovskites. These are some of the examples of the perovskite semiconductors which are being used for solar cells, like methylammonium lead iodide, methylammonium lead bromide, methylammonium lead iodide chloride, and ferroaluminum lead iodide. So these are some of the semiconductors which are basically used for solar cell fabrication, and that's the crystal structure of one of the materials, methylammonium lead iodide. Okay, so I just mentioned that the perovskite solar cells is not the only solar cell technology known so far. There are a number of solar cell technology, and some of them are already in the market, and maybe also seen them somewhere on the rooftop or on the streets. So, like for example, silicon solar cells, they are the first generation solar cell, and thin film solar cells, CIGS, CDT, amorphous solar cells, and the emerging PV, like dye sensor solar cells, perovskite solar cells, organic solar cells, quantum dot solar cells, all those solar cells. So they are basically the emerging technology, and that's the third generation solar cell technologies. So this chart basically compares the year-wise progress in different solar cell technologies. So you can see the perovskite solar cells. So these built with the orange color, with the yellow color, that represents the progress of the perovskite solar cells. The perovskite solar cells were discovered in 2009, and at that time the efficiency was around 4% only, 3.8%. But since then, now you can see just within a decade, the efficiency has gone beyond 25%. So certified efficiency is 25.7%. So just within a decade, the efficiency has gone many times, more than 6 times. So that's the only precedented progress in their performance in such a short span of the time. But not only that, actually. Silicon solar cell, I think you might be knowing, but and you might have seen silicon solar cell, but I don't know how many of you have the solar cells in your houses. There will be hardly few, because one of the reasons behind is that they are not very affordable actually. So these perovskite solar cells will not be the affordable to all. They will be highly cost effective, and but they are basically processed from the solutions. The semiconductor which we use, they are in the solution form, and those solutions can be printed on the substrate. So basically you can print them and you can make printable plastic rolls, and you can make them roll-to-roll printable perovskite solar cells. Not only that, they will be very thin, flexible, lightweight, and aesthetically very attractive. Maybe I'll show you some of the solar cells which we have already prepared over here, and you can also make them semi-transparent for window applications. Not only that, because they are flexible, you can apply them on any kind of surfaces, on the roof of the house, on the facades, and even they work very well in the diffuse light. So not only that, their installation and deinstallation will be very fast, very quick, and they have very short payback time, and their carbon footprint will be very low compared to the other solar cell technologies. So these are some of the important features of perovskite solar cells over the other solar cell technologies. But these solar cells are not in the market yet. And let me tell you why actually. For the commercial success of any solar cell technology, there are 3 very important parameters: the cost, efficiency, and the durability. So I already mentioned that the efficiency of perovskite solar cells has already gone beyond 25%. It is as good as silicon. Silicon is around 26.7%. So the efficiency is at par compared to the already conventional solar cells which are already in the market. So efficiency is the cost. I already mentioned you about that they are highly cost effective. You can print them and on the plastics roll to roll. So cost is a parameter because the material cost, fabrication cost, even the processing cost, all these things are very low compared to any other solar cell technology. So the perovskite solar cell technology will be the most cost effective solar cell technology known so far actually. The only problem for that which is keeping them from the market is their durability. They are not very stable at the moment. So the scientific community is working very hard on that aspect, and they are trying to make them not, basically they will not be as stable as silicon solar cell, but definitely they want to make them as good as stable so that they can be commercially available. So we are working on that aspect, and soon you will see that this technology will be in the market and serve the society. They are the 2 electrode systems, one anode and one cathode, and the perovskite material is sandwiched between the 2 electrodes. The light is basically made incident. The ITO is optically transparent. So the light is made incident from the transparent this ITO side, and that is absorbed in the perovskite material, where the light photons are converted into electrons and holes. So electrons basically transport through the electron transport layer, get collected at the cathode, holes transport through the hole transport layer, get collected at the anode. In that way, you get total positive charge on the anode, negative charge on the cathode, and you get like, they just like work as a battery. So long you keep the light incident on the solar cell, they keep producing the electricity, and you can use them like a battery. So basically the materials, so you can see the semiconductors which we use for these solar cells are in the liquid form. So you can easily use them like the ink, like we use in the inkjet printers, and you can easily print them. So the synthesis of this perovskite semiconductor is quite easy. So basically, let me tell you the example of the methylammonium lead iodide. So methylammonium lead iodide is basically prepared by the chemical reaction between methylammonium iodide and lead iodide, and this methylammonium iodide is basically prepared by the chemical reaction between methylamine and hydroiodic acid. So all these reactions are basically done at the room temperature, and it's very easy to prepare the perovskite semiconductor. And let me tell you how we do that basically. So we take the lead iodide and methylammonium iodide in 1:1 molar ratio, and then we mix the two materials in DMF and stir them at around 60 degrees centigrade for around 12 hours, and after that we get a solution which we call the perovskite precursor actually, and that solution is ready for the printing. So what we do basically for the perovskite, either you can print them or you can do by the spin coating method. So when we deposit the perovskite on the substrate, they are basically in slightly yellowish form, but when we do the thermal annealing, then they convert into brown. So this brown film is an indication basically of the formation of the perovskite crystals. But so these are some of other structures we can prepare. We can basically prepare solar cells in the mesoporous structure, we can prepare them in the planar heterojunction structure, and even we can also prepare them in the inverted structure. So I'm not going to go into the detail of that. If you want to ask me about anything, you can just ask me whenever you want actually. Okay, so at NPL, basically we are developing these perovskite solar cells on both the glass as well as flexible plastic substrates. And we are also, for the R&D purpose, we need to make the solar cells in the small area for the optimization of different parameters of the solar cells. So we are basically developing these solar cells by both the techniques, by spin coating as well as by printing. So in case of spin coating, so on the plastic substrates, we have got around 13% efficiency. And in case of the flexible solar cell, and in case of the solar cells on the glass substrate, we have got around 15% efficiency. And all these solar cells are prepared by the spin coating technique. But you know, the spin coating technique is not feasible for the scale up of this technology. So if you want to basically go for the commercialization, you need to make them in the large area. And for the large area fabrication, the printing is the only method by which you can prepare them, you can fabricate them. So these are some of the printing methods which are being used or you can use for the printing of the perovskite solar cells. Like for example, the Dr. blade, the spray printing, screen printing, inkjet printing, solar die printing, and gateway printing. So these are some of the examples of the printing methods which we can use for the printing of these solar cells. So we are basically using that float die printing method at the moment for printing of solar cell at the NPL. Okay, so actually the printers are already available in the market, which you can use for the printing of the perovskite solar cells, but they are very expensive. So what we thought of, instead of buying those expensive equipment, why not we design and fabricate our own printer? So we at NPL have designed a very cost-effective printer, and basically that has completely been designed and developed, fabricated here in NPL, and that printer can print solar cells in up to A4 size on plastic as well as on the glass substrates. So, and the operation of that printer is being controlled by a computer software, computer program, and basically what we do for the printing, we have a print platform, the printer, and on that platform we put our substrate, let it be the glass substrate or a plastic substrate coated with the ITO. Then we print the electron transport layer, anneal it at the optimum conditions. Then we print on the top of that the electron transport layer, the perovskite layer, electron transport layer on ITO, and then perovskite layer on the ETL, and then whole transport layer on the perovskite. So all these layers are basically sequentially printed one on another, and they are basically dried and kept in the optimized conditions, and the thickness is also optimized for the optimum output of the solar cell. So to complete the solar cell, we need one top electrode of the metal. So we can also print the top electrode, but at the moment we are not printing it, we are just doing the thermal evaporation. So most of the electrode, like for example silver or copper or aluminum, we are doing by the thermal evaporation to complete the solar cell. So that's the how we are basically printing the solar cells here in NPL. The formation of the perovskite crystals are basically confirmed by their characterization, optical and structural characterizations. So these are the photographs of some of basically the printing of some of the materials on A4 size plastic sheets. So that is the printing of P3ST, and basically this is the printing of multi-layers of different materials, tin oxide, which basically we use as the electron transport layer, perovskite, and the P3ST, the whole transport layer. And I also have got those films with me just to show you that. So this is the printed P3ST on the plastic sheet using that printer, and so that's the printing of multiple layers on the plastic sheet, A4 size plastic sheets actually. Okay. Okay, so like I just mentioned that for the optimization of the different parameters of the solar cells, we need to prepare them just to minimize the our material loss and the time as well. We prepare them in the small area as well as in the large area as well. So in case of small area printed solar cells, we have achieved up to 8% efficiency, and the area of the solar cell was around 30 millimeters square. So and that was the structure of that solar cell. Similarly, in case of the glass substrates, we are also printing them in the small area. In a small area, we have achieved around 11.7% efficiency in a small area solar cell. The area was around 8.4 centimeters square. In case of modules, so this is the photograph of a module which which are basically 5 centimeter by 7 centimeter square in area, and that module has produced around 4.4% efficiency. And basically in this module we had 4 cells connected in series together. So the output voltage of the module was 3.6 volt, and it was generating basically around 55 milliampere of current. The active area and the output power was 81 milliwatt, and the active area of this module was 18.4 centimeters square. So that was on the plastic substrate. Similarly, on the glass substrate, so that is one of the modules on the glass substrate in 9 centimeter by 13 centimeter square area, and in that module we have achieved around 7 to 8% efficiency. So that particular module had 7.7% efficiency, and the power generated output was 500 milliwatt actually. So there were around 8 cells which were connected in series together, and the module produced around 7 volt with 134.8 milliampere of current actually. So we also prepared a panel actually. So by integrating 2 large area modules in parallel together, and that module, I think we have kept that module in our stall. So you can see if you want to have a look on that. So that module is producing around 1 watt of power, 1 watt of electricity actually. So here we connected the 2 modules in parallel together, and each module had the area of around 6 inch by 4 inch actually. And these are some of the other printed modules which were prepared on the glass as well as on the plastic as well as on the glass substrate. So this module is 13 by 15 centimeters square. So that's the one which basically is the first one, and you can see it's quite flexible and they are very durable actually. So that's one, and on the glass substrate, I think they are in my stall, so you can, if you want, you can go up there and see the other modules. So we are basically fabricating and developing the modules in small area as well as in the large area actually. Here is a very small video clip which shows the operation of an DC fan by the printed flexible perovskite solar cell actually. So you can see we will be folding this solar cell multiple times, and we have connected one DC fan with this solar cell, and it's working very well under 1 sun illumination intensity of the solar simulator. So we have tested the solar cell for multiple times bending, and we found that there was no hampering, there was no damage to their performance actually. So we have also, for the testing of their lifetime, we have also designed and developed one facility over here in NPL, where we can test basically the multiple solar cells all together under one sun illumination of the tungsten halogen lamps actually. So we, in this facility, we can test 9 cells all together, and we have also prepared a control box to select which solar cell we want to test actually. So we can measure the automatically, this is the automatic setup. So we can test and record the IV characteristics and the photovoltaic parameters, and along with that we are also recording the humidity and the temperature of the surrounding environment, just to see the effect of the humidity and temperature on the solar cell performance actually. So just to share with you some of the results of the lifetime testing of our printed solar cell. So we, that is under one sun illumination intensity 100 milliwatt per centimeter square. So the solar cell were continuously exposed to the sun, not exactly the sunlight, but the halogen lamp light, but at the same intensity as one sun has actually. So you can see that they are not very durable, means the durability is not very appreciable at the moment, but we are working on that aspect, and soon we are expecting that we will be improving their stability further. But if you want to just see the stability at the moment, you can see they are going down to their 50% of their efficiency in around 250 hours. So you know, sun will not be there for all the time. So if we consider that there will be around 8 to 10 hours sunlight a day, then the stability of these modules will be around 25 to 30 days, around a month actually, depending upon the sunlight exposure. So in future, we are thinking of developing these roll-to-roll printed perovskite solar cells, and we have got enough hands-on experience on developing these solar cells. But because at the moment they are very expensive equipment, so we are also thinking of developing some kind of indigenously developed roll-to-roll printer, by which we can also print the solar cells roll-to-roll over here, and we will be doing that in the near future, definitely. So, and these are some of the applications of these printed solar cells. So there is no limitation of their application. They have got enormous applications. So you can put them on any for automobile vehicles, because nowadays we talk about the EVs, electric vehicles. So electric vehicles, for charging the battery, if you put the solar cell on the top of the vehicle itself, we need not to have the charging stations. So that is those one application. You can also have rollable, foldable mobile chargers, your laptop chargers, and you can also put them on the roofs, rooftop applications. You can also put them in the solar parks or in the bus stands. You can also put them on the hat, bags, jackets. You can make these power jackets, wearable power jackets, and by wearing that power jackets when you are walking on the street, so just by walking on the street, you can charge your mobile phones or your iPad or whatever device you are carrying with you. So these are some of the applications of these printed perovskite solar cells. So the main thing is that there is no limitation in their applications, but the main point which I want to emphasize is that they can reach anywhere, even in the areas where silicon solar cell cannot, because silicon solar cells are very bulky, they are very heavy, and they are not flexible. So they have got the applications which the silicon solar cells have not got yet actually. So I'm not saying that they're gonna replace silicon solar cells, no, but definitely they have the capability to move with the silicon solar cells hand in hand in future, and definitely they will be playing a very important role for future energy generation for various applications actually. I think that was my last slide. Thank you very much for your kind attention. If you have any question, please go ahead. Yes, please.
So, you are consider inverted structure for your printing technology.
Okay.
Inverted structure and regular structure. There is
Yeah.
So why you consider inverted structure? What is the advantage of inverted structure?
Yeah, advantage of inverted
Is it
structure.
possible to do in regular structure also?
The perovskite solar cells,
No, printing technology.
the printing technology. No,
You consider instead of whole transport layer, you put in the last.
yeah, this is the one, na?
No, not one. Inverted structure.
The inverted this one, no?
But you are using regular structure.
The regular structures, yes.
Not inverted.
Yes.
Why you consider regular structure, not inverted?
We can use the inverted. Okay, his question is, I don't know whether anybody else is listening. So his question is that we are using the normal structure for printing of the perovskite solar cells. Why we are not using the inverted structure? So we can definitely use the inverted structure as well. There is no limitation, because the only thing is that the material you are using, they should be not processed at high temperature, because some of the materials which we use, like suppose for example the titanium oxide. So titanium oxide is processed at very high temperature. So you cannot go for high temperature beyond 150, around 150, because plastic will not sustain that high temperature. So the materials which you can process at low temperature, you can use them, and they should be solution processable. So if they are solution processable at room temperature, you can use them. So irrespective of the normal structure or the inverted structure, if your material is processable at room temperature in liquid form, you can use them for printing.
Okay.
What is your annealing temperature for this case?
In this case, actually the annealing temperature depends upon the material you are using. So for example, in our solar cell, the electron transport layer, we are using the tin oxide. Okay, not the titanium oxide. For titanium oxide, we need to process them at around 500 degrees centigrade to convert to them in the anodized phase. So, but in case of titanium, in case of tin oxide, we are just processing them around 120 degrees centigrade, 130 degrees centigrade. So, at 120, 130 degrees centigrade, the plastic substrates doesn't have damage. So, that's very good material for the printing purpose for the solar cells. We are using the tin oxide.
Have you ever tried those materials with the sputtering system or something like that?
Which materials?
TiO2, anodized phase?
No, we have not tried TiO2 by sputtering method, though we are not using TiO2 for printing application. That is one thing. So printing, we are using tin oxide. But yes, for the glass substrates, we are using tin oxide, titanium oxide. So, but we are not doing it by sputtering. We are doing it by sol gel method.
So, well, you have presented a very nice talk, and one of my question is about the stability of these solar cells. What is the stability of these solar cells?
See, the stability of my solar cells, I already told you in the slides. Do you want me to show you?
No, just tell me how much hour or something like that.
See, I just told you that if you keep, we are not testing them in the sunlight directly now. We are testing them in the tungsten halogen lamp. So we are exposing them continuously, 24 hours for under the tungsten halogen lamp, and they are going down to 50% of their initial efficiency in around 250 hours. But if you just imagine that the sun, if you keep them in sunlight, I understand the actual operating conditions will be more harsh than the inside laboratory conditions. So we are basically going to do that as well. But if you just consider 10 to 8 hours exposure of sunlight per day, then you can expect the average stability would be around 25 days or 30 days, around a month.
So, well, if it is 30 days, or if we can have at least for 1 year, right? Then how much waste you gonna create, because it is flexible on the plastic. So is there any strategy for recycling of these things?
Yes, obviously there will be a strategy, because all these materials are recyclable materials. So they are prepared on the plastic you can recycle, and all the materials which basically we use, the metals or even the perovskites. So you can easily extract them out and you can recycle them. So they are highly recyclable solar cells.
Any more question? Yeah, I have one question.
Yes, please.
It's a very interesting talk.
Thank you.
Nowadays, just as we all know, silicon solar cells are very much useful. I'm not talking about the stability. There's still a scope for the improvement, and the R&D is going on. When you talk about it in terms of efficiency, silicon solar cell which we are using in the home is 18 to 20%, I think so. In the laboratory, up to 22%, something reports are there.
Okay.
When we talk about perovskite solar cell, what are the numbers? We are not talking about the stability. In the initial stage, what are the maximum numbers which are available? The people can think it can sometimes be better perform than the silicon solar cell.
Okay, see, basically this is the chart from NREL USA, and it compares the efficiency of different solar cell technologies. So if we just compare the silicon one and the perovskite one, so silicon single crystal non-concentrator is this one, 26.1%, 26.1%, yes. So 26.1% efficiency in case of silicon and 25.7% in case of perovskite solar cell.
That is,
So internationally, they are at par. Yes, they are very near to each other actually.
thank you.
Yeah.
Thank you, Dr. Pankaj. It was excellent talk.
Thank you.
I just want to have your comment regarding the future of this perovskite solar cell, whether they are going to, there is a possibility of replacing them the silicon or not. I am asking because I am very much confident about that thing, but I have heard from somebody that it is not at all going to work. So I just want your comment as an expert.
See, anybody can say anything. So we have to see. See, we cannot stop people saying anything, but in science, anything is possible. But it's not like that I'm speculating the things. We are giving you the proof as well. See, when things start, I just showed you that the perovskite solar cells started in 2009, and at that time the efficiency was around 3.8% only. But now the efficiency has gone beyond 25%. So it is improving. Yes, one more thing. I agree, the stability of my solar cells are not very much, but internationally it is reported that they are very stable, more than a year in direct sunlight actually. So you can't say, see, if you want to commercialize them, you have to see three parameters: cost, efficiency, and their durability. Cost is very low, efficiency is as good as the silicon, the only thing is the durability. If you make them 5 to 10 years stable, definitely they are going to give good competition to the silicon one. I'm not saying they will replace the silicon, but definitely they can go hand in hand with silicon, and they have got different applications. They have got the applications where silicon solar cell cannot be used actually. So from that point of view, I would say personally that they have got a bright future, but I'm not going to say anything if you say no, they don't have any. We can argue and we can discuss about it, but we can prove that they have a bright future. And definitely, let me tell you one more thing, that there is a company in the UK, so they are basically integrating the perovskite solar cells with the silicon solar cells. So if the perovskite solar cells doesn't come into the market alone, they will definitely come with the silicon solar cells in the turndown form. So people are working on all sorts of possibilities of using these perovskite materials or the solar cells for to make them usable as soon as possible. Definitely, yes, yes. So the same thing was told. Yeah, you are correct. You are absolutely right. People were used to talk about the organic semiconductors. So we know the organic semiconductors are very sensitive. If you expose them to the light or the oxygen moisture, they start degrading. So when we were working on the organic light emitting dirt, people used to say the same thing, that the OLEDs will not work. I agree that there is no any Indian company which has actually produced the OLEDs, but there are international companies which are producing the OLEDs and we are using them now. So we can doubt about our capabilities. Definitely, if I am not able to do it, I can say this is not going to work. But I cannot doubt the capabilities of others. Maybe they have the potential. They can take it to the next level. So that's my opinion. Yeah. Any other question from anybody? Thank you. I've been here for a couple of, many people have already interacted, but if you still feel that you want to ask anything, I'm still there till evening. You can come to the stall and discuss with me and have a feel of the solar cells which you are developing, which you are fabricating over here in NPL.
कॉपी निकालना पड़ेगा सर। ये क्या
ये तो अच्छा इसको मैंने सेव कर दिया था। नहीं तो स्किप करेंगे तो बंद हो जाएगा।
कॉपी करना है कि डायरेक्टली यहीं से चलाऊँ मैं?
कॉपी कर देते हैं।
ये और ये वाला और ये वाला।
ये है सर,
ये वाला और तीसरे वाला।
एक ये वीडियो है क्या?
हाँ ये कॉलर कॉलर माइक।
कॉलर माइक माइक
साउंड तो नहीं है सर, ऑडियो है?
हाँ?
वीडियो में ऑडियो देना है क्या?
हाँ देना है।
ऑन कर दिए प्रेजेंटेशन कहाँ है?
एक बार चेक करिए ऑडियो आ रहा है।
ये पहले, हाँ पहले ऑडियो से।
आ रहा है? हाँ? देख, आ गया। बस बंद कर।
Hello. Now, next talk is from Mr. Ranjit Roy, Ecom Ecotech Industry, Indore, and the office is Delhi also. So now I would like to request Mr. Ranjit Roy, please deliver a talk. Okay.
Thank you, sir. Thank you, sir, and good morning to everyone. I am Ranjit Roy, and I am representing Ecom Ecotech Industries Private Limited. We'll just have a snapshot and what we do in Ecom and what are products we'll just discuss in the next half an hour. So the snapshot overview, we will start as I said that with me there are two more colleagues. Amit is there and Harsh is there. I will introduce at the end of the session. For the summary, we have first the Ecom Industries introduction, then we will discuss about the India operation, third is the environmental solutions, fourth is industrial reliability solutions, and last our key team members. So before I start the presentation, I would just want to play one short video about our facility in Indore. वीडियो को देखो, वो नहीं आ नहीं रहा, इसको बंद करो पहले। सर वो एक्चुअली इंटरनेट नहीं है, नहीं तो उससे चल जाता। डुप्लीकेट में उसको।
True sustainability is balanced with meeting the needs of future generations. It is a delicate balance between growth and conservation, exploring and preservation, and being open to new possibilities. At ACOM, our focus on balance is creating environments of possibility. For more than 50 years, ACOM has been designing and manufacturing class-leading multi-parameter environmental monitoring and industrial reliability solutions. We are committed to helping organizations find the right balance between progress and preservation, safeguarding businesses and others. Our 850-plus employees work across 28 offices, 6 manufacturing facilities, and 5 R&D centers in 11 countries, provide trusted, holistic data solutions for customers worldwide. ACOM India's corporate office is located in Vadodara. We also have regional offices in Delhi and Hyderabad, and a manufacturing facility in Pithampur. More than 200 service engineers across India. We are always close to our customers.
From the basement of our family home in Melbourne, Australia, to becoming a global leader in environmental monitoring, it was my father, Robert Del Sasso, whose passion, drive and determination is monitored in more than 80 countries. His small business grew on the back of hard work, investment in technology and building trusted partnerships. He positioned what was there.
Quality assessment starting with the pre-test process. Soft testing of the product for various parameters ensure that integration of all parts is being performed successfully.
ACOM India's advanced in-house testing facility is ISO 9001 and TUV certified, with sophisticated equipment used for real-time simulations and performance testing. Our plant has an A-class zero air setup, which filters out intake air impurity and produces 100% zero air, providing testing surety. To ensure that every product works throughout its life cycle, various performance tests are carried out, including span and zero drift, span and zero noise, multi-point linearity, detectable limits. All products then undergo a final technical inspection for aesthetics and defect-free operation. Best-in-class materials are used for packaging our products that are shipped worldwide. Once the products are commissioned, they need to be calibrated periodically to continue working accurately throughout their lifetime. ACOM India provides calibration, service, and warranty support to our customers. We also offer online monitoring and analytic services of our equipment installed at more than 500 sites around the world every day. From major cities to mine sites and coastlines to jungle canopies, ACOM air quality, noise, and dust solutions manufactured by ACOM in India help to protect industries, communities, and the environment around the world. We take pride in knowing that ACOM ambient air and tunnel monitoring solutions produced in our facility have been commissioned and installed in the world's longest high-altitude single-tube tunnel, the Atal Tunnel, built under the Himalayas' famed Rohtang Pass in northern India. The products and technology we manufacture and supply are supported by our extensive and experienced operations and maintenance teams, spread across every region and state in India, and backed by our accredited repair and calibration centers. While our network and sectors grow across India, we have our own thriving ecosystem, working quietly and relentlessly to make sure that our systems perform to the highest industry standards. They are our people. With progress comes responsibility to create better outcomes for human development and the environment. Accurate and timely analysis of environmental data is the way forward for a sustainable future. For 5 decades, we have provided innovative solutions that have empowered industries to limit their environmental impact. ACOM, creating environments of possibility.
Hope you have enjoyed the video, and in India, ACOM India plays a very important role. We'll discuss in length how ACOM India plays a very important role in the environment field. So creating environment of possibilities, this is our mission, and this is the tagline of ACOM worldwide. So who we are, what is there in ACOM group? We are 150 million euro turnover, about 150 plus employees, 220 partners, spread across 9 locations, 28 offices, 6 plants, and 5 R&D centers. So among 6 plants, India plays a very, very major and a very, very important role in the ACOM instruments. Let's go back to the history and how the ACOM has been formed. So if you see, in 1967, Metric Foundation Vibration Engineering was the first, technology or the engineering product which has been come out. And from there, 1987 was 01 dB on the vibration and the sound. Defense threat detections in 1995, 2000 Arriva nuclear energy, 2017 Ecotech air quality from where you see our factory in Indore, then 215 vibration alignment integration shaft alignment, 2050 fixture leisure, 2011 ACOM berth was here. So all throughout this year, if you see, this is all acquisition and partnership. And now how we are here in ACOM Ecotech Industries Private Limited in India. 2019 Air Monitix Dynoptech tunnel sensors. We have just seen the video of a tunnel, Atal tunnel, where the tunnel sensors are placed in, and then the reliability point, reliability services, and Met1 instruments, which is the newest and a very recent acquisition in ACOM Group. We operate out of 5 LOBs. LOBs means line of business. Number 1 is the industrial reliability. Number 2 is the emission and process. Number 3 is the ambient and monitoring. Number 4th is the protection, and number 5th is the design. Since today's topic is all about environment, we will talk more on emission and process and ambient monitoring. We deliver meaningful data to take the right decision. Now, what is the meaningful data? If you see at the left-hand side, extreme left-hand side, we have all the measurement, that means we analyze the thing. We have the acoustic, we have the air and particles, we have emissions and gases, whereby vibrations, we have alignment, and many more. But these are the 5 major parameters from where the measurement or the analysis has been done. So from here, from the sensors, we basically captures the data, we take it to the cloud computing, we do a computing, and then finally the report has been generated. So that's the reason we are saying that we deliver a meaningful data to take the right decision. That means in one umbrella, we measure, we compute it, and then we generate the data. So as I mentioned in the previous slide, that we operate out of 5 LOBs, that's line of business. The first one is the industrial reliability. What we do in industrial reliability, basically we do a machine monitoring kind of testing or machine monitoring of measurement, where we do a reliability of asset, we do condition monitoring of the shaft alignment, we do online wireless, offline solution, augmented mechanics. And what are the applications? The digital manufacturing, we do in oil and gas, we do in wind, we do in automotive and paper industry. So how much is the install base here? Our capability is 100K plus worldwide and 100K plus at the qualified diagnostic at the north. This is what we are capable of. We are giving services in this industrial reliability LOB. Next is the emission and process, the topic of today. What we monitor continuous emission, we monitor opacity, we monitor dust, we monitor particulates. We even monitor tunnel sensors, which is nowadays in every infrastructure, wherever the tunnel is there, let it be a road tunnel or a railway tunnel, there has also to be maintained, we have to also measure the air quality inside the tunnel. So this is tunnel sensor, the visibility, air flow and luminescence. And then again, what is the application? We have the industrial process and we have the tunnel atmosphere as well. So our capability is 600 plus monitors per year we manufacture and we install, and 240 plus tunnels we monitored. Next is ambient monitoring, which is again one of the major topic nowadays, especially where we are sitting in India, in Delhi. So what we monitor is noise and vibration, meteorological monitoring, gas particulates and emissions, outdoor and indoor air quality, blast, dust and fence lining monitoring. Similarly, what are the applications? Smart cities, airports, port, construction and mining, health and safety, school, aged care. This is basically on the hospitality where the senior citizens are being taken care. So our capabilities, 3200 plus monitors per year we have installed, 1200 plus stations we have monitored so far. Protection, this is a very interesting topic. In fact, we always discuss about this topic in a defense line. What? The gunshot detection. Wherever the gunshot has been, it's been occurred, we can analyze from the point where the gunshot has happened. Then acoustic threat detection and the noise radar. What are the application? Defense, site, vehicle protection, drones, robots, augmented soldiers and civil protection. Civil protection is nothing but our local polices where we can find the gunshot is happening. Our capabilities, again, 40 plus equipped armies in the world we have already has been supplied, 35 plus vehicles program integrated. This is one of the biggest strength of EcoM. What we do is basically, we not only we measure it, not only we compute it, but we also design the program as per the required application. So this is one of the major thing which we do worldwide. Even in India, we do a customization of your requirement, of your any software you required from our side to measure it, to analyze it, we are there. So what we do is basically materials dynamic mechanical analysis, vibration and noise mitigation solutions, R&D design and assistance, health monitoring and lightweight, oil and gas, aerospace, defense, transport, polymers and rubbers industries. What is our capability in services? We have already supplied 500 plus machines in the world, 200 plus engineering projects per year. So this is one of the very important and strength of EcoM. Let's now talk about India operation, how we can help the nations and how we are delivering India and we are giving to the world. As you've seen in the plant where we manufacture our world-class gas analyzers in terms of ambient gas analyzers. It is in Pithampur, almost 30 to 40 kilometers from Indore. This is 100% owned subsidiary of EcoM Group. Established operation in 2015. Manufactured at Pithampur near Indore. Established Ecotech monitoring solution for supporting environment and OM services. As in the last previous slides, I have mentioned that Ecotech was one of the company who has come in India and started its manufacturing of gas analysis in India. Now Ecotech was acquired by EcoM in 2017. That's the reason in India the trade name of our company is EcoM Ecotech Industries Private Limited. 150 plus employees we are there in India. pan-India network of service engineers. How we are spread in India? Our 4 office locations, Vadodara is our head office, Indore is our manufacturing office, Delhi NCR, we have a team of almost 12 to 13 on the commercial part, but we have more than 50 plus engineers who are working on different sides of AQMS. And Hyderabad, we have an operation and maintenance complete support system to support all the ambient air quality monitoring systems. Remote diagnostic centers and repair calibration center at Vadodara we have in a remote way. What is the key aspects of India as Asia and Middle East? From India, we are also covering Southeast Asia and the Middle East market. Diversified, balanced business portfolio across maintenance and environment division. Pan-India presence of specialized and skilled teams. Vibration analytics CAT 1, 2 and 3 as per the ISO standards. Dedicated operation and maintenance teams for air and real-time noise monitoring stations. Valued partnership with all major corporates and PCBs pollution control boards in India. Speed, scalability, consistent and vast network across. India delivers solutions to all critical customers' requirements. So this is a snapshot of the glimpse of our factory in Pithampur. Now coming to the main topic, that's called continuous ambient air monitoring systems for the environment for today's topic. What are the common pollutants we see in especially a city like Delhi? SO2 is there, CO is there, O3 is there, ozone is there, CO2 is there, NO is there, NO2 is there, H2S is there, VOC is there, and last but not the least, HF is also there. But yes, HF, we do not have a major industries in India, in Delhi, in and around Delhi. So HF we can neglect. But rest of all the pollutants you can see in Delhi, and we are really concerned about it. General requirements of a monitoring of a CSIR-NPL, that's continuous ambient air quality monitoring systems. All the analyzers and the method has to be USCP approved analyzers. Certification of satisfactory performance from the users. Capability to furnish the information in desired report format. Data capture rate should be more than 90%. That's a criteria from Central Pollution Control Board that your uptime of the analyzers of the instrument has to be more than 90%. Facility of remote data transfer. Right upon standard operating procedures and quality assurance with the calibration procedures. What are the analyzers available and what do we measure in an ppm level as well as in a trace level? Ecotech air sampling system, which is again one of the main products which we manufactured in Pithampur. Ozone analyzer, CO2 analyzer, NO2 analyzer, CO analyzer, NOx analyzer, SO2 analyzer, ammonia analyzer, H2S analyzer, total sulfur and TRS analyzer. So these are the main component which we manufacture here in Pithampur. And then beyond that, what we give after this analyzer has been manufactured? We give a complete integrated systems. Like we give a complete shelter, we install the analyzers, we compute the values which is coming out from the analyzers, and then we generate a report as per the requirement of the Pollution Control Board we give the report, or it is a USCP approved, or it is a local reports which is available in the market. Now coming to the technology, what are the technologies available for all those measurement? MO converter with again in chemiluminescence. Ozone we do with the UV photometry, SO2 we do with UV fluorescence, CO NDR photometry gas filter corrosion, which we commonly say as a GFC, then BTX gas chromatography, which again we do as a PID, particulate matter beta ray attenuation, black carbon filter based multiple wavelength optical absorption, methane and other hydrocarbons we do again with the gas chromatography PID method. Coming to the ozone, the analyzer looks something like this, and the model which we say as Serenus 10. Serenus is the series of our gas analyzer which has been manufactured in India and in Australia, and it has been manufactured here in India and we supply to the rest of the world. Then comes the CO analyzer, which is we say as a Serenus 30. Then comes the SO2 analyzer, which we say as a Serenus 50. Then we say Serenus 44, which is multiple measurement of NOx and ammonia. Then we say as BAM, that's called beta attenuation for PM2.5, PM10, which is again our own brand. BTX analyzer, which we do as a gas chromatography. Then MET1 black carbon, which is again talk of the town nowadays. Like people, pollution control boards are looking for a black carbon analyzer as well. So this is one again. The method is same as the PM2.5, PM10. That's beta attenuation method we do as a black carbon. Then nephlometers, which is again I was personally discussing with CPCB, and then the topic came out that yes, the stations are being maintained, the analyzers have been maintained, but how about validating the whole data? So this is another one component or the one instrument, nephlometer, which we say it is one of the most requirement in AQMS or CAQMS. Without this, I think you are not able to validate the the reading which is coming out from the analyzers. Data logger, again CPCB and the Pollution Control Board says that your data should be unmanned. That means there shouldn't be any kind of a person or human interfaces in there. So in that, this is a black box. We do not do anything, just sending the data to the server, to the cloud. The software is built by our own, because these models are called as Congrego. The hardware is Congrego and the software is also the Congrego. So both are complementing to each other. Data acquisition and control systems designed by environmental monitoring experts specially for air quality continuous emission. Simple setup, easy to install with an initiate customer user interface. The most important part is fulfills the traceability of requirement of ISO 17025, which is required for an CAQMS station. How does the software looks or the report is generated from an AQMS or by calibration is one of the major part of any analyzer. Analyzers, we will not able to understand how our analyzers are reacting. So very important, and we have that facility. All those things, one major things we always miss out is the meteorological parameter. Because with the meteorological parameter, it is complementing the CAQMS data as well. So we have temperature, relative humidity, rainfall, barometric pressure, solar radiation, vertical wind speed, wind direction. And relative technique has been, we do with that one. The best part of AQMS, I just want to emphasize here is the complete CAQMS or the environment monitoring. We have all the hardwares, we have all the software under one umbrella. We are not dependent with any third party or outside manufacturers for these systems. Some photographs. So we have state pollution control boards, almost 237 installation, PSUs and private organization about 150, which is spread across pan India. So is just a repeatability, eco stations or road tunnel. These sensors has to be monitored, and these sensors again has to monitor the same matters or the same gases which are being monitored in the cities or in the rural area. So tunnel monitoring systems, this is how it looks like. Airport flight tracking monitoring, construction site monitoring, building acoustic indoor and outdoor noise mapping. So this is the last but not the least LOBs, that's a line of business, is called Industrial Reliability and Solutions. We do shaft alignment, we do geometric measurement, machine tool measurement, augmented mechanical solutions. Then condition monitoring systems, real-time monitoring and diagnostic, wireless diagnostic, continuous monitoring. Offline, we do a smart vibration analyzer, come balancer, instant machine health checkers. Sensors for condition monitoring, again, this is our in-house. This is all the sensors are been manufactured in France and we give it to industries. Acoustic based condition monitoring, acoustic cameras are there, intensity localization systems are there from the reliability solution LOB. So these are the services and the, what we provide from industrial reliability. We are all recently NPL and CPCB with the joint ventures. We have taken one service order for your noise vibration, which is being in an execution process. Trainings are very, very important in our organization. We have an internal trainer and also we have an external trainer. I would request all the delegates, if you can visit our AQM Pithampur factory, you will understand the procedures, we understand the international methods, what we apply in those manufacturing processes. 150 plus air noise quality monitoring stations across India, experienced team of field services, technician, mechanical engineers, software and engineers and scientists. Calibration services in-house we do. We are not dependent on the third party. So we are the first company in environment which came out with IoT, technique, artificial intelligence and people to create a performance and sustainable world of all of us. Our key members, Mr. Samir Sabnis, who is the managing directors, Mr. Vineet Jain, director of operations, who is based out of Pithampur. I am here and I am looking after the environment division, and Mr. Manjul Pandey, who is looking after the industrial reliability division. That's all from my side. Any questions, please? Sir, I'm not able to hear you.
Hello?
Yes, sir.
Your presentation is very good.
Thank you, thank you.
Nice picture of your thing. And if I understand, you are doing a lot of manufacturing the monitoring and analyzers on this point.
Right.
In fact, you said that daily there is some kind of monitoring is going on.
Yes.
So, how do you compare with the other manufacturers because that's basically the people that we need to go for the tech thermometers and other part. So I would like to see that how you are specifically planning to have that work.
Sir, as I mentioned in my slides that we are ISO, USCP and UV certified company. The same method, the same certificate we are using here in India. So our analyzer, if you go to the website, you will find that AQM India is one of the part of it. So we, as an manufacturing company, we are the only company in the world who manufactures gas analyzers in India with the same technology, with the same method from our parent group from Australia. Basically, the Australian people only came and set up the Ecotech manufacturing unit in Pithampur. So from there, it's AQM Ecotech Industries Private Limited. So our analyzers are the international standards, and we supply these analyzers not for the domestic purpose, but to the whole world. From here, it goes to the other parts of the world as well.
You have found that you are promoting the one.
Yes, sir. Yeah. Sir, that part is yet to start the manufacturing, but yes, very soon.
There is a big market recently captured by the Acrometer by Navy Scientific. and you are using the mate one because that's the one of the monitor. What are the basically the way, because we are taking a lot of basically your market in the not only India also. Particularly India is that all the administrators are the monitor are basically like administrators everywhere. So how do you basically contribute those part and what the way you are doing?
So I think Harsh, my colleague, he can answer this question very well. Harsh?
As you say that you are doing the things you are talking about that, but my one what is that there is a inherent problem with the bank. I think Dr. Sankar and with the right in the past, there is a inherent problem with the bank, ranges of the capturing your particular. Am I correct? In the BAM there is some kind of range. So since you are using the BAM method for your method on the black camera monitor, how basically you are answered the question of, I think the anxiety, or I don't know the question, anxiety of the implement of the server, what we have basically said that BAM cannot do. So that's the basic.
So you are using Met1 BAM only? It's a Met1 beta attenuation?
Yeah, actually, the problem in the beta attenuation in India is because the concentration range in India is too high, right?
Right.
So in most of the cases, if you have attenuation data,
Right.
and for each company they have fixed this attenuation coefficient,
Right.
and attenuation coefficients depends on the mass density.
Right.
So mass density means
Right.
in India the composition of particle is always changing.
Always changing.
Because in winter it has some different.
Right.
Some constant may not be correct if you put for 12 months.
Right.
So this is the issue when you use it, say in summer, because in summer mostly the dust particles.
Right.
So it's okay, more or less.
Right.
But
in winter.
as you go, from October to February, we found that yes, there is a major bias of the readings. So it is because of the attenuation coefficient.
Right.
So what we did, as Dr. Mandal just said, so we try to make one calibration, on-site calibration instrument, which is already developed now, and we have all correction and everything. And now we are going to transfer this technology very soon. We are looking for some partner who can get this technology, so they can produce it, commercially. And we also tell to a CBCB that each and every monitoration should have this instrument to calibrate. On-site calibration is important, and at least every month they need to calibrate it.
Right.
Yeah, so I'm just giving the answer. Right now, what we are doing is basically for the range basically. So we are just doing the calibration for in every hour. Just it's a spend check with the membrane. Okay. So the concentration of membrane is around 900 microgram per meter per centimeter square. So we are doing it at every hour. And as you said, that so there is a difference between the coefficient. So right now, once in a 6 months, we are doing the calibration through the high volume samplers also at the site, at the same co-location study. So if there is any changes, so we are trying to find out it. And of course, if you have developed such a new kind of technology, we are happy to collaborate with you. And if it is because you know that using a high volume sampler is quite difficult because we have to take a sample for 24 hours, and then on 24 hours we can't differentiate that the density of the particles are getting changed in every hour to hour, and BAM is giving the reading every hour. So it's quite difficult, but as you said, that if it is a new technology, we will be happy to follow. And I hope you are aware that we are just very soon we are going to manufacture these BAMs in India also. So it's under the process, and maybe in the next 2-3 months we will start. So we can, of course, for the calibration at the factory level, we need such kind of technology.
So I'll be happy that AOChem basically what the Dr. Shankar has already developed, if you collaborate, because that should be the partner between EACO and the Dr. Shankar and the NPL. It will be good initiative. So what he has already done and what these are scientific issues, he can already solve the issues. It will be for you to take those solutions, and rather than going for some of the part. And if you do it, probably I will say that you can compete with the accelerometer, because there is no such accelerometer. Maggie does not have that kind of solution. So I hope that through the MSME and industry meet collaboration, you can meet and you can see that what Dr. Shankar has done it, and try to take get the solution from Dr. Shankar. I think I do.
Thank you, sir. Sir, we will surely collaborate with you. And Harsh, please take a note. We will have a one-to-one meeting on that, person meeting, and then we'll see what the best we can do for NPL, sir. Thank you, sir. Thank you very much. Any other question?
Any other question? It's a very interesting talk, and
Thank
a lot
you.
of discussion with Dr. Mandal and Dr. Shankar Agrawal.
Thank you, sir. আমি আসবো আপনার কাছে আসবো এসে কথা বলবো থ্যাংক ইউ
Now we have a next talk by Mr. Ashish Bhatt from the temperature and humidity standard. He is basically discussing about one of the stall which you must have seen, the testing facility for IR clinical thermometer. It's a very important activity of NPL. You should all focus on that. It's a very interesting talk. Yeah, please come.
नेक्स्ट करने का कौन सा सर इसमें नेक्स्ट करना है नहीं सर यही वाली खोल दो कॉपी करके डेस्कटॉप पे ले लो इनको ऑफ नहीं हो जाती थी कॉपी कर लो सर लास्ट राइट ऑफ हाँ कॉपी करके डेस्कटॉप में यहीं से ऑन कर दो यहीं से ऑन कर देता है सर इनका पीपीटी बन ओके स्क्रीन पे डाली लो A very good afternoon all everyone. I am Ashish Bhatt as a senior research fellow from CSIR National Physical Laboratory and Temperature and Humidity Group.
Today I will discuss here the development of calibration and testing facility of clinical thermometer at CSIR-NPL. Actually, in the COVID duration, many manufacturers made IR thermometers, but how to calibrate this any devices and how to sell in our market. So in CSIR-NPL, within few days, developed this calibration setup, and already 2-3 setups already in our country. Now, in this the content of my presentation, a scope of thermometry measurement at CSIR-NPL, traceability of clinical thermometry, introduction to clinical thermometry and IR clinical thermometers, development of calibration and testing facility in IR thermometers in CSIR-NPL, and measurement survey on the behalf of this calibration technique, result and conclusion. Now, this is the scope of thermometry in NPL. Is the basically the ITS 90 according to the international temperature scale is -196 to 3000 degrees C. In clinical temperature range basically 35 degrees Celsius to 42 degrees Celsius, and the uncertainty in acceptance criteria 0.03 degrees Celsius, and the stability of the bath is a 0.01. The calibration testing of for model approval in liquid in glass thermometer, digital thermometer, IR thermometer in 0.2 acceptance criteria as a per standard ISO, and IR thermometers, forehead thermometer like a non-contact device in the source uncertainty within 0.06 degrees C with stability is 0.01. Source design, development, and as per international standard calibration and testing for model approval. Now, so the traceability to the clinical thermometer is basically in the SI unit. Here the uncertainty is approximately 0. Now the TPW, triple point of water, and ITS 90 fixed point to traceable our system. CSIR-NPL is a National Meteorological Institute of our country. So basically define the many fixed point and traceable this. So the clinical range between 35 degrees Celsius to 43 degrees Celsius, the main 3 ITS pointy, one is the triple point of water, another is the gallium, another is the indium. All SPRTs calibrate in these 3 points and then traceable our system. So here the calibration lab setup, legal meteorological project, and CSIR-NPL in participate this problem and already achieved this area of the acceptance criteria is 0.3 degrees Celsius in the clinical thermometers. Now, these are the clinical thermometers. Basically, in a starting of clinical thermometer in the liquid in glass thermometers are the capillary and mercury bulb here. This mercury is very sensitive to temperature, then expand volume in this side in the range of the clinical thermometry. But why mercury-free clinical thermometry? In some time, our mercury glass thermometer is break, then this mercury is openly move in environment, and this is a very toxic element. Our health issues in many problem, food issues, liquid, then the toxic elements. So reduce this mercury for healthcare. So now the design digital thermometers like IR thermometer, and another is a more important problem in some small child inside this thermometer mouth. If you break this thermometer, then mercury inside in mouth, and this is many problems. And another problem, this is a contact thermometer, one inside one person mouth, then other to another person mouth, then the contamination one to each other. Then the other problem is this contamination, how to remove. In COVID duration, the COVID virus is the contamination, and this problem is solved by a non-contact thermometer. So this is many problems of mercury, and main target in the meteorological community is decided that electronical based thermometer basically have replaced in the traditional mercury and another liquid in glass thermometer for safety purpose than the superiority. Now, this is a high need IR thermometer. Basically, IR thermometer is basically principle in the radiation principle. The all operator is thermal radiation emitted by any object to relating this their the temperature. Now, this is the basically Planck radiation law, and the important another in IR thermometers is a very quick response as compared to the contact thermometer. So advantage of IR thermometer is this is a non-contact appliance devices. It is a no any contamination. Another is a easy to use and cleanly use. Measure the temperature and display is a reading as a rapidly provide the ability in the retake a temperature quickly. So this is our human body. Basically, human body in a major cavity. So the air thermometers all inside the mouth is the digital thermometer and LIGT thermometers, auxiliary temperature, another is a rectal temperature for the babies. And the World Health Organization approved the 4 fever diagnosis in the part. So IRT devices is the converted basically thermal energy into the electrical signal and display in the form of temperature. In COVID duration, in the contact device, one person to another person contaminate the virus and many diseases and will rapidly increase COVID case. So non-contact thermometer device in many available market, but no any traceable system in our country. So in few days, September 2020, CSIR-NPL developed this facility and many thermometers are calibrated and many thermometers are calibrated and accepted the criteria of the according to the ISO. So the many types of thermometers in a thermopile sensor, and in these figures, this is not a good measurement technique because the many point is not correct. This is not correct because the angle versus ratio is not good, but this is a correct scenario because in this is a sensor part and this is our target. So here if our target is an object inside the focus, so this is a very good and accurate temperature reader. This is a critical situation, this is an incorrect side. It means target, object and sensor. Distance is a very important parameter, object versus our sensor. So performance is depends on the measurement from the contact body side, contact measurement with distance with target and object, appropriate as the environmental condition and handling. It means a perfect trained observer use this setup. So it need the standard of the IR clinical thermometer, CSIR-NPL developed in testing facility for IR clinical thermometers according to the ISO document number 80601-256 in 2017. The acceptance criteria of clinical thermometer is 0.3 degrees C in this range. So this is our setup in the high stability bath. In the uniformity of this bath is 5 millikelvin. And another, this is a black body, copper black body cavity. The black body emissivity is 0.998 degrees C, and this is our device under the calibration of clinical thermometer and standard pyrometers. Another is the SPRT. This SPRT is maintain the stability of bath by contact method, and this is the cavity is emitted thermal radiation and absorb this thermometer in these and so that temperature inside of this body. So all part in design in house made, and the facility is already this system in all different areas. So 10% humidity to 95% humidity inside chamber, and all thermometers traceable and calibrate in this setup. Now next is the calibration setup is for IR thermometers. This is a very important, the emissivity of this black body cavity. All design in house made, and inside of this black body is a graphite powder spray in a coating. So the emissivity of different, one aperture size is R1, another aperture size is R2. The difference between of the emissivity of both setup is 0.92 and 0.99. So this is a more aperture sizes depends on the black body emissivity. So the testing facility is already achieved in CSIR-NPL and developed this whole facility in the chamber of the environmental humidity condition is 10% relative humidity to 80% relative humidity at 10%, and similarly 10% RS to 80% RS in 40 degrees C. This is the clinical range already fulfill this condition. Now this is the experimental setup. In this, suppose that here are 4 types thermometer in different temperature range, and these temperature include our body temperature range, but we can see here in the ET4, in the air thermometer 4 device, from standard as temperature increases. It means this thermometer is not fulfill criteria condition. It means this is a defect piece in our samples. Now this is the uncertainty of the measurement setup in the according to the ISO document. The uncertainty of the source within 0.07 degrees. It means stability of bath is basically 17. Bath is 5 millikelvin. So more precise and accurate value of our bath in this temperature range, clinical temperature range, the total expended uncertainty of the references depend on different all parameters, and in these parameters, emissivity, temperature gradient, homogeneity, stability of bath, all are parameters, and the expended uncertainty is within a criteria. So overall uncertainty of the under device calibration IR thermometer is 0.1 degree Celsius. Now this is another problem in COVID duration, the contamination two person face to face, one disease to another virus in affected. So how to solve this problem? So new ideas is generated if distance between of both persons in the reach temperature versus forest temperature approximately equivalent. So in generally mall, metro stations are persons in randomly quick heart and hand, but measurement is not proper. Any person is front of heart is palm side, back side, that is not a good measurement. But and generally in face-to-face contact is some persons is nervous in between laser light put in our hand, our head. So some problem here. So reached versus forehead correlation in result correction in our CSIR-NPL. All CSIR-NPL members participate in this survey, and after survey we have conclusion in the different four parts is the forehead, wrist, palm and back end. So here the different random. So in this data, palm and back end basically scatter is more value because our hand is a scattering thermal radiation, not a proper good result in our human body, but forehead and wrist both are accurate approximately within acceptance criteria. We can see here the forehead versus average contact digital thermometer in this is a digital thermometer in effect is a constant, but forehead and is scattered in this way, and this is a regression between forehead versus digital in the close to basically 1. So forehead thermometer has uncertainty in 0.1 degree C without any error. The least count of this device is a 0.1, and contact thermometer has uncertainty is 0.1 without any error is least count of 1. So both are meteorological correlation of acceptance criteria within 0.3 degrees Celsius according to the ISO document number. So forehead and wrist site measurement we can see here in this graph. Both temperature of same person is approximately within criteria, and some persons are elevated and many another problems. But ISO document according to 0.3 acceptance criteria fulfill in wrist versus forehead temperature. It means wrist temperature and forehead temperature is approximately equal. Now this is a specificity of the forehead and wrist side measurement in 93% persons data is fulfill this criteria within 0.3 uncertainty acceptance criteria of this setup. So now the conclusion of last in a testing facility of IR clinical thermometer has been successfully established at CSIR-NPL. This is a in-house research and development effort, several testing several models, COVID-19 pandemic situation, and help the serve in MSME. Temperature has been established. Reached site was specific of 93% can be used to measure the body temperature in contamination disease situations. So all the reached is easily assembled as forehead. It is a meteorologically correct and safer for the methods. So thank you so much for your kind attention. Thank you, sir.
Nice. Anybody having any question?
Actually, like you said about the non-contact thermometer is good. So my question is, like, what is the optimum distance at which we should place the thermometer to measure the temperature?
Okay. Yeah, you can see here. PPT. Yeah, you can see here the sensor and the distance of the target versus sensor distance basically depend on the source of aperture. The focus length of our focus, lensing focus, and distance of so S/D ratio. So the perfect design in the focus is cover this area. That area is we find the temperature of the any object and target. So the distance effect in already we can see in this bath. So this is a measurement in length scale and the complete fulfill criteria. So this ratio depends on the distance between source and target.
So it basically decided by the focal length of the.
Yes. Focal length and source of aperture source. जहाँ से हमारे thermal radiations emits हो रहे हैं.
Okay, thank you.
Welcome.
हेलो आशीष.
Yes.
जो सवाल मेरा है कि जो तुम मटेरियल्स यूज़ कर रहे हो ब्लैक बॉडी बनाने के लिए, what is the actual composition of that material?
Yeah, actual composition is basically in our setup is two types of material. One is a graphite. Graphite is a perfect graphite, is a 99.5% graphite, proper rod. Because the emissivity of graphite is approximately goes to 1. Is a 90% graphite is pure emissivity. So in another is a copper setup. Copper is a basically more thermal conductor. So inside the perfect black body paint and the mathematically calculation in these formulas, we have achieved this emissivity. So depends the inside the black body paint basically. The emissivity is more.
So basically you are using copper sheets and inside that you have had
Yeah, black
graphite
body.
powder coating.
Yes, yes.
Okay. Thank you.
Welcome.
Any other question? No more question. Actually, it is nicely explained by you.
Thank you,
It's
sir.
a very important technology for the country. Okay. So
Yes,
now,
sir.
I would like one more question, Dr. Agrawal.
Yeah, I think it's a very good presentation.
Thank you,
and
sir.
Being a student, I think it's one of the best presentations. So I congratulate you. My question is, did you try to transfer this technology? I mean, your supervisor maybe.
Yes.
So did you? Can you tell something about what's the plan for transfer of the technology? Do you know about it? Maybe no, right?
Speak loud actually, so sound is problem.
Okay, so my question is.
सर ये टेक्नोलॉजी हम लोग की अभी रेडी है, ठीक है, अभी अंडर पेटेंट है, तो पेटेंट होने के बाद हम लोग इसको ट्रांसफ़र के फॉर्म में जाएंगे और उससे पहले अभी लीगल मेट्रोलॉजी ने इसकी डिमांड की है हम लोगों से, हम लीगल मेट्रोलॉजी को सेटअप देंगे, उसके बाद ये पब्लिकली ओपन करेंगे.
Okay. Now, I would like to invite Dr. Agrawal to felicitate Mr. Ashish. Yeah. Now we have a lunch time, okay? So we all should go together for the lunch. After lunch, we will all come here around 2 o'clock, okay? The session will again start at 2 o'clock.
Hello, hello. So, very good afternoon. So again, we reassembled here after lunch. I hope that you must have a very good lunch today. And now we have 2 or 3 presentations. So first presentation is from NPL. It's from Mr. Amit Soni. He will present about his technology they have developed. It's from Dr. Ashok Group. They have developed blood pressure measuring instrument or instrumental technology. So he will present it, and then they are also looking for some collaborator. So if some industry can come up with some interest, they can contact them. So Amit Soni, please.
Hello, good afternoon all of you. I am Amit Soni, working under the supervision of Dr. Ashok Kumar as a senior research fellow. Today, here I am going to represent about human oscillometric waveform recorder, the device developed in our lab. First question, what is blood pressure? Blood pressure is pressure extracted by flowing blood on artery walls. The blood pressure is measured in terms of systolic and diastolic, where systolic blood pressure is the maximum pressure extracted on the artery walls, and diastolic blood pressure is minimum one. According to systolic and diastolic blood the values of systolic and diastolic blood pressure, the condition of heart can be characterized in several terms as explained in shown in figure. How can we measure blood pressure? First method is invasive technique, in which we insert a catheter in the artery and measure blood pressure in a glass tube. Here we found that the level of blood oscillate between 2 levels. The upper level is termed as systolic blood pressure, and lower one is diastolic blood pressure. On the another hand, a non-invasive blood pressure measurement technique, in which a manometer is used to measure blood pressure, in which a cuff is used. A cuff is used in upper arm, and by some mechanism we apply pressure on the cuff. We apply pressure above the systolic blood pressure to completely block the artery, and then start releasing pressure with the slow rate, and listen beep sound in stethoscope. The first beat during deflation, the first beat is correspond to the systolic blood pressure, and the last beat corresponding to diastolic blood pressure. Simultaneously, there are a lot of automated blood pressure devices are also available in the market. Most of these devices are based on oscillometric technique, in which we extract oscillations of cuff oscillations by some mathematical process, and the pressure corresponding to the maximum oscillation is termed as mean artery pressure, and diastolic and systolic blood pressure are calculated with the help of characteristic ratio. These devices are accurately work for regular pulses, but in the case of irregular pulses, the mean and standard deviations are slightly higher. To overcome this issue, we have developed a device whose graphical user interface are shown here. User can manually put personal and medical information which is helpful in the research purpose. After measurement, the calculated systolic and diastolic mean artery pressure, heart rate, pulse pressure, etc. are shown in the result section, and there are several buttons used to control its operation. The key features of the device is it can record oscillometric waveform. This waveform can store along with information in personal information and medical informations. After measurement, the device display the oscillometric waveform, and also it display the calculated values of systolic and diastolic blood pressure. There are some oscillometric waveform recorded with our devices. The first one shows the simulated results of regular pulses, and second and fourth represent the simulated results of irregular pulses. Then third one represents the recorded oscillometric waveform for various human. We also calculate mean and standard deviation in the case of simulator as well as for human subjects. Result shows that the mean and standard deviations are well below the universal standard protocol, which is mean error should be less than 5 mmHg and standard deviation should be less than 8 mmHg. Thank you.
Any questions? Any questions from the audience? So, if there is no question, so I thank Amit Soni for introducing your technology. Thank you very much. And I just want to, have a respect of token from us. So we have one token for you. Please accept it. We need to wait a little because the presenter is in lunch. So once he will back, then we'll start. So just take 10 minutes. Then whenever he will be available, we'll start. Okay, so now Dr. Praveen Sani is with us. So now he can deliver his talk. So he's a scientist in NPL. So I request him to come here and deliver his talk. Thank you very much.
कंटिन्यू कर लें भाई, है ना, टाइम लग जाएगा। बड़ी फाइल है इसमें। अच्छा, इसकी आवाज़ कहाँ तक रहेगी, मैं कहाँ तक मूव कर सकता हूँ? यहीं खड़े होकर करना पड़ेगा, मूव अराउंड नहीं कर सकता मैं। मूव वाला तो फिर लगाना पड़ेगा, दे दो अगर वो है तो। मैं ज़्यादा फिर उसमें फील करता हूँ। ठीक।
और आरोप एक मिनट।
Let me thank organizers for giving me this opportunity. So today I'll be talking about one of the most relevant topic these days, that is the waste. We utilize so many kind of materials, we do so many kind of technologies, but we may not bother about what happens to it at the end of its life. So it becomes more relevant in that sense. So let me take you through the tour. So you can see that there are so many kind of pictures flashing over the screen, and you already know that what is the status of the municipal solid waste in India and in globally itself. Globally we have this much volumes of the waste, and then when we talk about the India, almost 0.1 million tons of garbage is generated daily. So it's a huge problem, and if you see these kind of waste piling here and there, we have come to the situation where it is an unfortunate situation. We started comparing the landfills and their heights with our monuments like Qutub Minar. We say that the landfill has reached up to that much height. So height may not be the issue. The issue is that what exactly lying there, its manifestation, it's harmful. Common people are missing, or we may be wrongly transporting there. Like they may be looking for certain kind of plastics and other materials which are having the monetary value. These birds and these cows are looking for something that acts as a food. That means we are wasting the resources, we are wasting the materials, and we are complicating the problem, we are creating the pollution. And these kind of landfill fires, etc., are very much common these days because we have generated complicated kind of waste and we have transported them across the landfills. So there are serious consequences of these kind of things, like loss of resources,
wastage of the money, pollution and health hazards, global warming, etc., etc. So definitely we need to take care of these kind of waste, and the best practices for this is we need to somehow do something so that the waste may not reach these kind of landfill sites in that particular form. I mean, that means only that material goes somewhere where we have not any kind of solution, and that too it should be kept in the protected form. So let me take you another slide. It talks about the waste collection, which is the biggest problem that I have tried to highlight through the previous slide. We do not have the proper waste collection mechanism. So what will happen? We mix the waste and we transport it to the landfill site. So what will happen? Suppose we have a organic waste that we tend to talk about, it decompose easily, it can be converted into biogas, it can be converted into compost, this and that. But when we mix with the other kind of materials like polymers, so what will happen? Polymer tends to break the supply of the oxygen, water and other species, and microorganisms cannot work properly, and your aerobic condition may be converted into the anaerobic conditions, ultimately resulting in the emission of the methane. So what will happen? We are not only wasting the resources, we are complicating the situation, we are harming the environment, and we are investing so much in transferring those kinds of waste to these landfill sites. So some mechanism should be there in which each and every sector of the stakeholder should participate. For example, I mean, we should have this kind of dustbin kind of culture, whether it's a 4 or different kind of dustbin, that depends upon the type of the waste, but at least we can categorize them into the organic waste or maybe recyclable waste or some inert kind of materials and maybe the hazardous kind of. So these kind of practices partially followed in the hospitals and other areas, but not in the common localities. So that is the main problematic cause that causes the problem. So waste segregation, collection, and then its transportation to the proper recycling or maybe treatment facilities which can extract best out of it is the solution. So first of all, we need to think about these things, then only the other things comes like recycling and other parameters. So I'll give you a glimpse of the thing. What we have done, I mean, just when we started this kind of work few years back, we started with the plastic waste itself. So we have taken a certain kind of plastic material, we have tried to modify its properties and just comes out with a certain kind of basic element that is known as the tile or profile through the process that is known as the molding process. Basically, we have utilized the injection molding process. So many things have been done in this thing. I am not going into the detail, but definitely, ultimately, we come out with this kind of panel structure that when bolted or integrated can ultimately used to form a certain kind of 3D object, whether it's a cabin or whether it's any other article that can be made out of it, including your other kind of laying structures. But again, the question mark remains here is that whether they are competitive with the existing technology that we have to, I mean, ascertain before using any material. So this is the thing we have done very initially. But everybody knows that, I mean, the plastic molding, this and that is a matter of, I mean, it is a very common practice these days in the industry. For last 30-40 years, people know that you melt it, shape it. Definitely, I mean, to make something, you need to understand the flow of the material and how the material behaves in the presence of the other ingredients. But this is in the practice. So the problem that we have chosen at the initially is the complicated type of waste. And I am just going to give the example of complicated type of waste is the electronic waste. I mean, most of them is already lying here also. I mean, in the form of a mobiles, it is here in the form of a microphone, laptop, this and that. So everything is a e-waste. So we have a different categories of e-waste. You talk about energy storage systems, you talk about different electronic items and appliances, even the solar panels, and any instances of the material that uses the electronic related circuitry. So what will happen? What happens exactly? You must have seen so many kind of articles are coming, e-waste will do this, that global amount of e-waste is growing. So definitely we need to take care of these kind of materials in terms of the proper waste management, how to channelize that waste, and definitely in parallel we need to develop the technologies for the different kind of e-waste, whether integrated technology or in the parts that can be integrated at the later stage with the existing technologies. So just to give you an example, we have categorized e-waste into 3 general categories when we started. General electrical and electronic equipments, it's a very complicated system. Then comes the energy harvesting systems like solar panels, and then the energy storage systems like batteries. So you can see that in case of the general electronic and electrical waste, the waste volumes are high, both globally as well as in Indian context. Obviously, these figures have raised a bit. I am so sorry about the slides may not be, very recent one due to some malfunctioning in my laptop. So if there is some typing mistake or some parameter mistake, I am apologizing in advance. But this is the situation. If you see that solar panels or maybe the batteries, the waste volumes are low. But what exactly is happening? There is a fast deployment of the solar panel all over the country. And simultaneously, we will be having the electrical mobility driven programs in which batteries will be required for the not only electrical vehicles, but the solar based systems, standalone systems. So these waste volumes are rising very fast. So we have to be prepared in advance. So just to give you an example, what we have done in our lab initially, you know that how this kind of you can say that electronic waste are treated. So we cannot have a simultaneous system at the lab scale where we can treat the entire electronic item at once. So we have taken a model compound, that is the PCB, printed circuit board, which is the common element to most of the electronic appliances. So what we have found that generally these PCBs are burnt openly because the copper is lying there. People are not interested in the polymeric part. So they just burn it away and then they get the copper. So what we have done, we have tried to recover this polymeric part also, which has a certain material value, and if it is burned like this only, it only emits the hazardous gases and create the environmental pollution, besides leading to the loss of the resources. So we again converted into something into powdery form, and then metal is extracted by certain operations, and non-metals like basically the thermosetting materials, which cannot be processed like the thermoplastic materials that can be molded, is just recovered from here. And we then converted into certain, high temperature treatment under the inert condition into the activated form of a carbon that can have the different application. For example, because of the porous architecture, electrical conductivity and electrochemical stability, it may be used for the supercapacitor, water purification, EMI shielding, and number of application. Definitely fine tuning in the properties is required, but we have the capability to tune it according. So this is the one generalized work that I am presenting. And this is the process that we have adopted. I am talking about what exactly happens at the industrial scale, where they have this PCB. PCB has number of components mounted over it. So first of all, it has to be depopulated out of those components. So industrially, there are machines available which still are not very much efficient. So at the lab scale, we generally perform this simple heating operation under the closed conditions, and we just desoldered the materials, and then we recovered the things. And then we have taken this bare PCB, and with that we have started the operation. So that's how we have done it at our lab. And we know that when we scale up the process, what are the barriers and obstacles that are going to come, and accordingly we have some small scale equipments at our laboratory right now itself, with which we are now scaling up the process. But definitely it requires altogether different approach, altogether different kind of equipments, because the kind of shredders or kind of you can say that processing equipment that are required for these things may not be available at the very cheaper, or you can say that the affordable price for the common public. So we are working in simultaneously in that direction also, how we can custom make those kind of equipments. And these are certain operations that we have followed while realizing this, and then we have identified the composition, what we have realized, demonstrated it for the supercapacitor application. Again, I am not going to spend that much time over it. If anybody interested in that thing, they may come us to visit our lab certain time, and we can have the at-length discussions. So second component that I was talking about is the battery. So we have taken the lithium-ion battery, and there are cathode and anode. Accordingly, there are active materials over it. Generally, for example, in one particular chemistry, there is a lithium cobalt oxide. So we have extracted that lithium cobalt oxide. We have extracted the carbon out of it. And then what we have tried to do, we have tried to convert those materials into certain important forms that may be utilized for the same application or for the other applications like energy storage and EMI shielding again. So when we talk about the graphite, we know that it's a very pure graphite that is being used in the batteries. It is a very high grade graphite,
and only purification is required. So after purification, we again convert it into certain functional forms, like it may be considered as an instance of the upcycling, where it converted into the graphene oxide, and then we have again converted into different forms, including gels, coated, aerogels, etc., for the various applications. And again, we have demonstrated this with the help of dry cells also. So these are the certain, characterization of the materials that we obtained, whether it's a graphitic material or it's a lithium cobalt oxide, and we found that it is having the good characteristics. And these are the some of the application where we have demonstrated it. Like we have realized the 3D interconnected aerogels, and we have demonstrated these type of aerogels for water purification, where just putting that material inside the dye solution, you just stir it, within a jiffy it will immediately absorb all the dyes it is contained, it can be recovered, and these materials can be used n number of times. So this is the one such application. And another application there where we have demonstrated it is for the supercapacitor applications. So this is one such example, and another example that comes to our mind, and then we often face now these days, is the solar panel. So we know that solar panel is nothing, it's an energy conversion device, but again it has a certain well-defined end of life, which may happen at the same well-defined period, or maybe the early stage due to the early loss scenario. So this is the work that we have done with relation to the solar panels recycling. What we have taken the solar panel, taken its small part after shredding, ultimately freed it from the frame and junction box, and then when we have a solar material, we cut it to the small forms, and then we somehow tried to extract the solar cells lying therein by different operations. So these are the glass recovered, bus bars recovered, back sheet is recovered, even the EVA adhesive is recovered, solar cells are recovered, and then this is the pure silicon wafer that we have recovered from this solar cell by performing certain operation to remove the cathode and anode materials lying over it and different layers. So this serves as a source for making different type of materials for different applications. So again, this is one demonstration only. If anyone require the details, we can always there to share the more details. And then there is another complicated type of waste that we may talk about, is the waste pharmaceutical blisters. Everybody utilizes these blisters at our home, but what will happen, we generally throw it in the dustbin. Most of us throw in the dustbin, and when it goes to the dustbin, even sweeper may not be interested, because he is not fetching that much out of it, rather than having the money out of the PET bottle or something else. So it ultimately goes to the landfill, again wastage of the resources and complicating the situation of the landfill. So industrially there are processes available for this, where it can be converted into the finer form, and once it is pulverized, it lead to the separation of the materials, and it can be extracted by different techniques which separate the metal from the non-metal. But again, the powdery materials is inferior in quality, it cannot be used for the well-defined application, and it creates its own powdery hazard, because powder materials are very difficult to handle. So we have developed a chemical process for that also, in which it can be delaminated into the, you can say, polymeric part can be recovered in the flakes form, and then the solvent, it can be easily, you can eliminating it, and at the same time creating the value addition for. So again, it's a waste to wealth approach. And then so this is the crux of the things. We have this kind of blisters, and we can convert it into these two type of fractions in a very nominal operation, and the process is scalable. We have already identified it, but once we come upon a process of certain batch size, because these polymers occupy large amount of volume because of the lightweight. So until and unless we talk in terms of the kgs or maybe the tons, so it will become difficult to having the dialogue with the industry. So we are working upon that thing, and once we complete that exercise, definitely we'll talk about the life cycle assessment, emissions, or maybe the cost associated with this type of things. So we are very much aware of those questions if anybody has. And the last thing is that what we have done, we have just developed the process for the multi-layer plastics. We all have seen these kind of plastics, whether it's a packet of kurkure or chocolate or something else. So it seems like a case of the wrapper, but it is a multi-layered structure. It has a number of layers bind together to form a single layer. So and the most important thing is that it has a coating of the aluminum that acts as a barrier for moisture and oxygen. So what will happen, the presence of that thin layer of aluminum complicates the entire processing. Although it's a thermoplastic, but it cannot be processed through a common extruder facility, because if you try to move the material, it's simply not going to flow through the extruder. It leads to the formation of breakages, it leads to the formation of, you can say that the inferior quality products if you try to injection mold it. And similarly, if you try to convert it into the fuel by using the different technology, like our sister labs, IIP Dehradun have developed technology for conversion into the fuel. So it interferes, aluminum interferes there. Similarly, any other application you talk about, the aluminum is going to cause the problem. So what we have done, we have tried to again remove this aluminum, and now we have the aluminum free polymer that can be as good as the raw polymer itself, and it can be used for different applications. And this is the solution where we have confined the aluminum. So we can recover this aluminum also. So we are playing with this. Right now it is a bit, you can say that less efficient step for us, because of the recovery costs seems to be relatively high, but definitely we can overcome this thing also, and we are working upon it. So these are the some examples that we are doing, and again this is the picture that this how it looks like initially, and then after shredding, and then this is the clean MLP that we can obtain. So when we talk about the waste management problem, it is not only the role of the NPL or a scientist person is important. Every section of the society has to contribute in one way or the other. So what will happen, community level awareness have to be spread upon the students or common man for waste management, because management is the biggest issue. If we manage the waste, definitely we can channelize the waste, so it will be processed more efficiently, more effectively it can be recovered. If it is not managed, suppose you give me the e-waste that is dirt, that has all over it dirt wrapped over it, and it is lying with other kind of waste material. So first of all, I need to wash it, I need to clean it, so much water is involved, so much energy is involved. So we need to develop that kind of habits also. And generally what happens, the more than 90% waste is processed by the informal sector. So we need to possibly strengthen them. That is the most important issue. Otherwise we talk about so many industries are there, so many people are there to manage the waste, but bulk of the work is done by them only. So we need to think about that. And obviously we need to try to bridge the gap between the formal and informal sector, where the role of the science and technology comes, how we can develop the technology that may be affordable, that may be implemented at the small scale level, so that decentralized solutions may be provided. So this is all from my side. If you have any questions, I will be happy to answer. And if you require further explanation or want to see something, you can always visit our lab for the extended discussions. Thank you.
Very interesting talk. Okay. Any question?
Yeah, Praveen, is a very interesting talk, and there are few things which we know that the segregation of that this waste has to be done. Since last 10-15 years, all the governments are saying this, but where is the roadblock? Why we are not able to do it?
For that, I said different stakeholders have to be involved. Somehow the stakeholders have not been involved. Through the early stage itself, we need to grab the school and college students, through which only their family will become aware, and then only we can. The thing is that the implementation are not happening. We have the different kind of dustbin. You see, two kind of dustbin culture we have seen. But what will happen? Both the dustbin have the same kind of content, even if it is written, and it is not communicated properly. Suppose as a general person, I talk about dry and wet waste, गीला और सूखा कूड़ा. I am just giving example.
No, I do agree with you, but you know, we can convert lot of voters to a party, but we cannot convert our society to do the right things. So there is a roadblock. So somewhere it is like we are not able to communicate the message properly.
Yes,
right? So in the way you are saying that school children and families has to be educated, I think this media can play a very important role in there, like certain movies has to be there, right? Those movies has to be played in the schools. So right from the beginning, those students has to be educated.
Exactly. Shall I comment upon that thing also? You are very right that we have to provide them education. We need to provide them the training. But the most important thing is that for providing the education, for providing the training, a proper, you can say that a cell has to be there who will only coordinate with them. But otherwise, what will happen? I mean, you see, let me be very frank with you and very blunt here. What will happening? So many kind of videos are circulating over the Facebook, this and that. People become hero overnight. They are solving the solution. But if you look from the environmental viewpoint, they are polluting more rather than creating the environment. They are disturbing the economy rather than contributing toward the economy. So there is the problem. So somebody has to come with a certain logic and they need to be explained. जैसे मैंने अभी I talked about the सूखा और गीला कूड़ा की बात करते हैं. If I talk about somebody, a polythene that is just dipped in a water, so will it become the सूखा और गीला कूड़ा? किसी को पता ही नहीं. So we need to precisely define the things. Even the term single-use plastic, I am sorry to say that it's a platform and I am a government official, I am telling here, it is a bit debatable issue. So one has to take care of those things also. People are not aware of what exactly the waste. We are just replacing the polythene. We are coming out with certain solution and you go to the market, you see.
So who could be the best person than you? You are a polymer scientist and you can create certain platform like this.
Dr. S.P. Singh, I will be more than happy if somebody involve me somewhere and definitely I will try my best to communicate and then there are better persons available who can just convert those thought into the much better thoughts.
One more question on your lithium ion battery waste you are treating. I could see that you are saying you are having this, burning this cathode material and you are creating some graphene oxide there.
Right.
How come?
So actually we are extracting
cathode is what?
Actually what we are, yes, anode I am talking about. Cathode is lithium cobalt oxide.
Yeah.
Yes.
So can you show me that slide?
Yes. Most probably it is written here. Cathode material is lithium cobalt oxide and anode is the graphite.
This picture of graphene oxide. No, there was another picture where you are showing something.
Yes, please. What exactly?
Next slide. Yeah, this one. So you are saying graphitic oxide film and you are from the top you are coming cathode material.
Yes.
Right? And then your graphene oxide coming in here. So where is your lithium cobalt oxide? I didn't see.
Lithium cobalt oxide we are not, see.
Cathode was there, right? That's what
yes,
I was
yes.
confused.
See what has happened, lithium cobalt oxide we have left aside. We are talking about now the anode material. Graphite to graphene oxide to graphene aerogels and other applications, and we are demonstrating that only. It is just demonstrating things, more elaborative things can be shown at the later stage.
Because lithium means this recycling of cathode material is really very important issue compared to this anode material. Anybody can do this. But real challenge is there.
Yes, that we have recovered, we have identified its phase also. Probably, I think if I will be having the same. Actually, I am not having right now the XRD of the material. Otherwise, we have recovered.
I'm not going to tell you anything.
Yes.
That's what another question was this. When you are saying you have confirmed from the SAM, no. Anything can give this kind of picture.
Sir, what I am saying, you listen me first. Actually, I am saying right now I am having the same picture only. Had it been the case of the XRD picture, I could have shown you the exact idea about that thing. Somehow it is not there.
Good. Any other question? Yeah.
Dr. Praveen, I think your area of the research is very, very important. And, you know, in India, if you look, whenever I go outside, you know, I can see a lot of garbage, especially plastic and aluminum foils. So the important thing what Dr. Singh said, I agree with this, that segregation awareness in India, we need it, right?
Exactly.
And, you are the, you know, because you are the expert of this, how to segregate and what's the how we can utilize this waste. So just one suggestion, I'm
yes.
not sure that it may be good or not, but if you can make some movies, right? and some general
Pardon? Beg your pardon?
Movie.
A clip
Yeah,
or something.
clip.
Definitely,
and,
definitely.
and send to schools, especially our most of the school Jigyasa program may be very useful, because we need to literate our younger people, because now you cannot teach me and I cannot change
Yes.
my habit, but if you teach the younger people, the child they can change their habits.
We actually
and other thing, even in NPL, I can see I have one glass and I put my all, whenever I use A4 size pencil size cell, just I put it on this glass. So once it's become full, then I don't have to how to make it waste. So we need such kind of container even in our labs,
Exactly.
in our offices. So charity begins at home, So we can start from home, and you may be instrumental for this.
Definitely,
this is my suggestion. And,
definitely, your suggestion is very good. Actually, we have initiated that practice all before COVID time. We visited few schools and they actively participated, and then the pause came, and now we are reinitiating that thing. From the last open day itself, we started coordinating with so many schools, and hopefully we started getting their involvement also. They promised something, they started something.
Thank you very much.
Thank you.
So, yeah. Okay, now no more question. Yeah, it was very interesting talk by Dr. Parveen. Now, let's thank Dr. Parveen Saini. Okay. Now I would like to invite Dr. Shankar Agrawal to felicitate Dr. Parveen Saini. Now we have another talk with Dr. S.K. Dubey from the electromagnetic metrology section. We must have seen some of the technology which already been in this pavilion. So now I would like to invite Dr. S.K. Dubey to give a talk on the electromagnetic metrology section, or some discussion on the technology, whatever they have developed in the NPL, and very interesting to the society. Okay.
Shankar, Bhanu, Pankaj, who asked me to give a brief about electromagnetic metrology, and I don't have any kind of presentation, but I am here to discuss, because they just told me during this session, so I could not bring it, but that's not the case. I am going to tell you in more detail how we are trying to develop a environment-friendly radio monitoring system. Nowadays, you cannot live without mobile. And if you have a mobile, there are two things are there. First thing which is the connectivity. If a mobile phone is not connected to network, you will be not in a mental peace position. It means there may be information which you are not accessible to. The other one is, if you are having a mobile, there are two kinds of situation. First one, it is connected via a tower so that the network signals are coming to you. It means you are exposed to microwave radiation. And the second one, you are having the mobile which is having a 2-watt source. So you are having a microwave source in your pocket. It may impact your systems as well. So as per electromagnetic metrology is concerned, we are driven by IEEE guidelines, and we are following IEEE 1309, which talks about the radiated power density measurement, where E-field limits is being decided, and it is decided by Department of Telecommunication. So as per Department of Telecommunication is concerned, the ICNRP guidelines are reduced by 110. It means in case of 2G, 3G and 4G communication, earlier it was 0.45 watt per meter square. Now earlier it was 4.5 watt per meter square. Now it is 0.45 watt per meter square in the public convenience. Similarly, the 10 watt per meter square for higher frequency bands is being reduced to 1 watt per meter square. That is since 2012 September. It is based on the DOT guidelines, based on the reduction of ICNRP guidelines by 110 for all the frequency bands operational in India. So keeping in view of that, we have developed our own indigenous system for e-field generation. That is a temp cell, where we are capable to produce electric field up to 1000 volt per meter with an uncertainty of 0.6 volt per meter per 10 volt meter. That what is our accuracy, and it is of the order of PTB Germany in East USA, and we have participated in one intercomparison. As far as mobile phone devices are concerned, okay. As far as mobile phone devices are concerned, the exposure to any mobile phone device is being considered as a specific absorption rate. A specific absorption rate means how much radiation is being absorbed by an individual and what are the biological changes occur in the individual due to those exposure. That is driven in terms of watt per kg, and we have developed an indigenous system for that. We are having our own indigenous probe because the SAR is driven by a formula sigma E square by rho, where sigma is the conductivity. It is derived from the imaginary part of the dielectric constant. Electric field intensity I have discussed already. It is from the gradient between the two ports associated with the electric field terminal, and the density is a human being density by which the wireless device is being associated. So if you are having a wireless device, you are using it for a longer time, it may have a biological impact on you. To evaluate it, we measure SAR, and to measure SAR, we keep phone in a switch on mode and having a network connection built on. For a 20-minute call, we make a call for a 20-minute exposure, and by using that, we developed our own tissue simulating liquid, which we replicate with respect to the living human being as per IEEE standard 1528. It means a human being is converted into electrical parameters, and for that they have prescribed certain parameters where we develop our own tissue simulating liquids called phantom, and then we expose them for 20 minutes, and after exposing them for 20 minutes we get the electric field intensity in peak averaged value as well as the change in dielectric constant via the conductivity. And after using the same formula which we have discussed, that is sigma E square by rho, we are capable to measure the SAR value. If you dial *#07# from your phone, you will get the certified value from the owner associated with his mobile phone. These two technologies are readily available and available on NPL website for commercialization. As far as magnetic metrology is concerned, and 1 week 1 lab program has concerned, we have demonstrated 3 technologies here, and I will go one by one. Firstly, we have demonstrated a very ultra sensitive DC magnetic field sensor, which is varying from 1 microtesla to 800 microtesla with an accuracy of 0.1 microtesla. This system is indigenously developed, and it is a handhold system. It is capable to detect earth magnetization. It is having a compass inbuilt, and it is having a inbuilt parametric addition related to calibrated parameter. It means suppose this sensor is having any kind of deterioration in the performance, you can feed the calibrated values inside it. That much programmable sensor is available with us, so that we have demonstrated here in the our emporium. Secondly, we have demonstrated AC magnetic field probe. We have it is still in the process to develop meter for it. It is working from 10 megahertz to 30 kilohertz, and it is covering from 10 microtesla to 1 Tesla range. It is a broadband frequency range, and it is requested from various industrial partners. We are still in process to develop it, but we have developed the indigenous probe. Meters development part is in progress, and once we will develop, we will have all kind of calibration point insertion and other pointers associated with that. A part of that, we have also demonstrated a artificial hand which is capable to detect the biopremic signal from individuals, and it is capable to perform various kind of various kinds of activity of a non-hand man which is required to be done. As far as quantum metrology is concerned, in electromagnetic metrology sensor, we are working for the SI traceable microwave measurement, and we have established electromagnetic induced transparency based E-field measurement system at our lab. We are having EIT signal which is being exposed with respect to 2 laser system, and now we are moving towards vector E-field signal generation. As far as vector E-field signal generation, this is as per IEEE standard 1528/2022, and it states that instead of only measuring electric field, we should measure the electric field as with its vector 2. And if we are willing to have a vector signal, we require a electro-optical sensing mechanism. We are working for that. And with this, I want to say thanks to the organizers and thank you all. सर पूछिए दो
any question?
नहीं सर माइक से पूछो सर आप पैसे मत पूछो
Yeah, thank you. Of course, slides are missing, so it could be more interactive.
It's not missing. I was just told here
Anyway,
to speak.
Good, yeah, it's a nice presentation. Just one question. We are in talk with an industry partner. They are developing nanocrystalline magnetic cores, ribbons, by melt spinning. So 30 micron thick and around 2 centimeter width. So there are two things. First is they want to measure magnetic properties at different kilohertz applications. Is it possible? That is one thing. Yeah, so I think 100,
Up to
200, something
range?
like that.
Huh?
I don't exactly remember 100, 200 kilohertz, something like that. Is
No,
that
sir. I have told you when I am speaking, as of now we are having up to 30 kilohertz only.
Okay.
Very soon we will have up to 100 kilohertz, but up to 30 kilohertz magnetic properties are more than sufficient.
Okay.
You
that
are going to use that ribbon for memory storage? What application you are going to have for that?
That is for, I think, for transformer applications, if I recall.
Then it is never more than 10 kilowatts.
Yeah, so that range I don't exactly remember, but we are.
But now we are going to start a indigenous system-based magnetic field measurement from 10 hertz to 30 kilohertz very soon. We are in process to get a CFCT approval for charges. That is the first job. And very soon you will have a 1 megahertz system followed by up to gigahertz system. It is our 3-year plan. Within 3 years, NPL will have a microwave and magnetic measurement in gigahertz range also.
So sample size like 30 micron thick?
Yes, okay. Whatever sample size, we actually, I request you to visit our lab and have the sensors tip. It is a very narrow one. It's only of the order of micron. We will
second thing, like what they have observed, once they are fabricating, they have a high B set value. But after some time, that B set value is changing. It is iron-based alloy, iron, boron, some like Finland.
I am willing to tell you a story. Professor Budhani was there. So they came up with some ferrite kind of structure, and all of a sudden they have some problem because they have a failure rate more than 80%. So they wanted to get rectified from NPL. So as it is a ferrite material, they come to microwave group and ask measure the shielding effectiveness. When we are measuring, sometime it is half of what they have claiming. Sometime it is 1/4 even. But we are, as a microwave people, we are not developing material people, so we are not knowing what is happening inside the material. Ultimately, it was a material preparation problem. The person who is using the press, he is having some kind of leniency to his job and is not doing it properly. So the force was not applied properly. So the ferrite is being porous and the shielding effectiveness get reduced. That was the reason at the time.
So
the same may be there. You just go by the process. Try to follow 17034. You people are expert. SP Singh is here. You are here. So try to implement 17034. Maybe the problem will resolve.
Okay. Thank you.
Pankaj have a question. Ji Pankaj, ask.
Actually, my question might be a little bit stupid question, but still I want to ask.
No, sir. No question is stupid, sir.
So my question is related to your artificial hand, actually. So your artificial hand.
Yes.
I had an opportunity to have a look on that and even test it, and basically tied that hand on my hand and saw the movement. So basically, when you hold your hand, hold your fingers, your hand was basically all the fingers were moving all together. So it's good if you want to grab something But my question is regarding the movement of individual fingers.
That's a very good question. We are even try to address during the display at our items. We have submitted a technology to transformation project where we are committed that we will give each and every movement of the finger to the hand also. Effectively, when you are willing to pull something, then at that time it is working, but the demo which is shown here, it is not working individually. Suppose you want to pull a pencil from a single tip, it is not possible by then. It will do by this only.
Right.
So now we are in process to do that. We are installing the motors at individual finger and try to control it.
No, in that case, that your artificial hand is for somebody doesn't has this hand or finger. Okay, if you are gonna tie your sensors on the finger.
No, we are not going to apply sensor here, sir. We are just, if you have seen, have you seen that one? We have applied sensor here.
Right.
What that person is trying to do, he is just pulling a force here.
Yes.
And by this force, it is a Hall based, it's a magnetic sensor, MR sensor. And by using this one, a voltage is being generated which allow your hand to be fold on or open to be.
Right.
Whatever construction and what we have installed through that one.
Right.
We will do programming in a very stepped manner towards each and every finger.
Yes.
So that when individual want to do only 2 fingers job, it can do. That is our next challenge which we are working.
But that is the concept I want to understand, because you're gonna tie that sensor somewhere on the
No,
hand.
we will try here only, sir.
So you're gonna tie that sensor in the hand. How will you make sure if you just want to move my little finger?
Sir, it's a technology constraint. I don't tell you. We will have it. You will use it. Now I'm not going to let you know the programming steps.
Okay.
If you are willing, you are NPL guy here. You come and visit the lab. Have it.
No, I don't.
If you want to know that programming step, you can visit. We have nothing to hide.
Okay. Thank you very much.
Any other question, sir?
One more question, Dr. SP Singh.
Sir.
You have wonderfully explained certain things of this SAR absorption and cell phones. What is your view about this 5G spectrum? And how this will gonna affect the human health? Because lot of articles are around in the literature on the internet. People are talking all nonsense in there. What is your view in that?
It's a no problem. I will answer in my capacity what I understood. Okay?
Because people are saying that you have psychological problem
no problem.
and lot many things.
Correct. So if you are willing to understand 5G, there are 2 parts of it. First one, what we are using. Now we are having a 5G in our signal. It is not above 6 gigahertz. It is more or less government has decided to be below 7.2 gigahertz. So it is maximum 3600, 5800 for Wi-Fi, like that they are doing. There is another 5G which is at millimeter wave. So the news which you are reading associated with 5G, it is at millimeter wave. When I am saying it as millimeter wave, it is started from 28 gigahertz and it is going up to 43 gigahertz. So in that range, sir, be honest to you, when you have I am just telling you, suppose you have a tower, it is having a 20 watt power to be radiated maximally. Its reach is not more than 50 meter. It means you needed repeaters. Because we are living in a very dense society, we need to be connected each and every one. Being 5G means they are not going to increase the intensity. They are going to allow you more bandwidth by allowing them a more directive way to attract you. It means they are going to do beam forming associated with their measurement. If they are going to do it, means it is man-to-man marking kind of situation. They are going to know what is your location so that they can try to connect you each and every time. So obviously government has taken care this very much, and up to this range which is available in India, it is good. Because they are not...
But if you are saying that in the millimeter range, so there is more chances of interacting those electromagnetic waves with the human body, and definitely there are risks associated because now instead of gamma rays and all those, they have the small wavelength. The large wavelength has more interaction time with your tissue.
I'm replying to that one. Sir, in 5G communication at millimeter wave, international practice is
communicate with the fiber optic media as much as it is possible. Only between two buildings where fiber networking is not possible, try to be associated in the term of that microwave communication, because they cannot go beyond 20 feet, 30 feet, 50 feet, because this frequency is 43 gigahertz. It will not be have of a 30 lambda more than 50 feet. So in that, just let me complete, sir. In that scenario, India is not yet prepared as per optical level is concerned. That's why they choose to be in this frequency domain only, where they don't require much more correction in the existing communication system.
4G system.
Huh.
Right? So another quick question is,
sir,
people when they use their mobile, right? Most of the time, the heating in the mobile, when we are talking and they say, okay, battery is getting heated.
Correct.
But this is not exactly the case. There are some kind of a reflection of electromagnetic waves as well, which is contributing to that.
I'm telling you that reply also. Sir, I have told you a number star has 07 has to be dialed. If you will dial, if you are having a OnePlus mobile phone, it is showing 1.6 watt per kg. Sir, if you go by the definition, 1.6 watt per kg, it means 1 gram of your healthy tissue is being converted to an irreversible process. It means they are not healthy as per IEEE. If you talk to a human being for a 20 minutes, that's what the definition says. It means आपने अपना नुकसान कर लिया भाई. अब as far as heating is concerned, what you have raised, now antenna is being framed at two places and they are having arrays, and if you are not having a energy dissipation mechanism properly, then it is going to be heated. It is not the battery alone responsible. Battery alone will be responsible. If you want to check it, keep your phone in switch off mode for minimum 20 minutes and then get it charged. If it is heating, then it is associated with battery only. Otherwise, it is a typical communication problem which is generating heat.
Yeah, this is because this question I asked for the information of the
Thank you,
general
sir.
public
Thank you.
as well, you know, because
Praveen Saini have a question.
Very
Saini
nice,
साहब पूछिए.
Dr. Dubey, it's a question or rather a comment. I mean, you are the better one to answer that thing. I mean, when we talk about the 4G and 5G, so generally people talk about its harmful effects here and there. News are coming. So I just wanted, curious enough to understand whether it has something to do with the penetrating power of the radiation. Number one, and then the distribution of the.
Sir, formula is very simple. You have a pipeline that where you have to flow the data. Everybody wants more water. आपके घर में टैप आता है ना सर, हर आदमी ने पंप लगा रखा है, किसी पे सबमर्सिबल है, किसी पे टुल्लू है. People are trying to catch more power in more priority. That's what is the case. People needed more bandwidth to transfer more data. If you needed more bandwidth, you could not be in the same 2G era. It had to be enhanced. In 2G era, 50 megahertz band was there. Now people are offering around 1 gigahertz band. At this time, NIST is coming a concept of network sharing. It means they are going to give you 2 gigahertz, 3 gigahertz, 4 gigahertz band, and they are going to ready to share if this band is free, have a sharing it on charge basis.
So that is quite clear. I just wanted to understand that whether it is more harmful or not, because I understand that when we move toward the 5G, it may be having the less penetrating power. So it may be less harmful. That is my understanding.
सर बहुत सिंपल फिलॉसफी है, लोग दोनों में कंफ्यूज कर जाते हैं. आपके फोन को जानते हैं सर, जैसे ही आप ऐसे जोन में जाएंगे, जब वहाँ कनेक्टिविटी वीक होगी, वो 2 वाट का सोर्स ऑन कर लेगा, ऐसे वो 1 वाट के सोर्स पे काम करता है सर. तो आपने 30 dBm कहा, तुरंत ही जो है 40 dBm कर लिया सर पावर. ऐसे क्या फायदा हुआ आपको? आप ये सर देखो, टेक्नोलॉजी का जो काम है ना, वो आपको कंफर्ट देना है सर. अगर आप कंफर्ट लेने के बजाय उसको अवॉइड करना चाहते हो, उससे दूर होने में भलाई. Sense is, what I try to explain in my talk associated with exposure, use your mobile as less as possible. It's just a connecting device. Don't make it as a entertainment device and your video calling device and all. And use it very wisely. Otherwise, it will use you. That's it.
So maybe, more specific talk can be, shared by you, because it's a very important topic. Our generations are using the mobiles, and, if the clarity is not there to us people. I mean,
No, clarity is very much there, sir. Each and everything is written on your mobile description also.
Dubey, actually it is written there, but are we competent enough to understand that thing? There sometimes.
No, sir. They have written about the usage also. Just go and read Apple's uses your phone section. Then you will realize what I'm trying to say.
Because what happens, I am citing you one example. There is a one company that is openly selling its device by saying the Diwar Tod router. So you can understand if somebody is selling the device with such a high signal sending capacity, what it may be doing to the person who is in the vicinity.
Sir,
so that's why I'm saying.
Sir, that's why people should go by the expert's advice. It is not wise to have a Wi-Fi router on your table if you are sitting nearby the table itself.
So
similarly, you should not install Wi-Fi in your bedroom unless and until you have a proper meshing arrangement for that.
So that's what exactly I'm asking you to do sometime so that more people get aware of those things.
Okay.
So, generally not aware.
I will try. That point is valid.
Thank you.
I would like to add in there, because this is a very good thing what Praveen has asked, and as you also answered. But Praveen, first of all, as I said in your presentation as well, like when you were talking about waste management, and the way he is also telling that we should be careful about, first of all, we should have a sense of humanity, and we should know that we are living for ourselves, not for others. A simple example of this society is, we go to the market, वहाँ पूरी धूल उड़ रही होती है और हम पानी पूरी खा रहे होते हैं, how many bacteria are going? So how you think that you can educate those people in that way? So better, slowly and slowly, like one example, one student was using this HF in my lab openly, and in US, in my lab, nobody can use HF without having a proper training. So the work culture has to be redefined, and we have to educate people more and more. This is what is required. And first of all, पेपर पब्लिश करने से ज़्यादा, रिसर्च करने से ज़्यादा उन्हें ये बताना चाहिए कि भैया तुम्हें जिंदा रहना है. So take safety measures. Safety measures को हम नहीं लेते.
ठीक है सर, correct.
I think no more question. Let's thank Dr. S.K. Dubey for an excellent talk and discussion regarding the electromagnetic waves and the problems in the society.
Give the opportunity. I am really thankful to you and Shankar.
Now I would invite Dr. Pankaj to felicitate Dr. Dubey. Yes.
So good afternoon, everyone. And now we have this final and concluding session of this, where we're going to have a panel discussion along with the experts and along with our this industry partners. So I invite Mr. Ranjit for this. So to the dais, and Dr. Shankar Agarwal, Dr. Bhanu, you please be on the dais. And who else? And so I request a representative from this QA testing laboratories to join us on the panel discussion, if someone is there. And is this okay? So well, I'll ask Dr. Shankar Agarwal to brief about this MSME meet.
Okay, thank you very much. I think it's my pleasure. Yeah. Thank you very much. So it's my pleasure to to part of this panel discussion. So first of all, I would like to thank everyone. In 3 days, this MSME meet, you all attended very nicely and spent time. So we have many good feedback. So just to summarize you that we have from 18th morning, we got an inauguration of this MSME meet. Then we have installed here exhibition, and then also from NPL new technologies. You have seen all this, and then every day 2 or 3 new industry partners we got here. So almost 23 industries attended this MSME meet in 3 days, and we had 13 lecture from them, and also 7 lecture from NPL, the technologies which are coming up or already in the final form. So almost 20 lectures we had. So I think the aim was this kind of MSME industry meet was to have some collaboration, future collaboration, and whatever we had with the industry to showcase their products. And in the first day also we got 3 MOU signed, 1 technology transfer, 1 research project MOU signed, and also 1 B&D release. So it's almost very successful. But once you have a successful program, means we also listen a lot of problem faced by MSME, and also what they expect from NPL side. So I think most of them, the common opinion was, when we interact with them, that the one common suggestion or common view is that right now, and what we do, we develop some technology and ask industry to join hands. So they say that, sir, we have a lot of problem, the social problem, or the gap area. So industries know very well. So if industry come first and then see our expertise where we can help them, it would be better. So involvement of the industry in the beginning, or with the call by industry, is better than once you develop the any technology and then ask the industry to come up. So this is the common question what I heard and many people are saying. So now NPL will see and maybe make a mechanism that industry first can come, contact to our scientists, and then we can accordingly work together at very beginning stage and then develop some technologies or some product. So this is the first opinion I saw in this. So this is my,
Thank you,
observation.
Dr. Agrawal, for summarizing in brief the theme of this particular event and the 3 days activity. Now I request Mr. Ranjit Roy, the Director Sale of ECOM, to represent, to give an overview what he felt about this particular program and his, how industry and NPL should interact for the development, growth of this Indian economy.
Thank you, sir. First of all, I would like to thank NPL and the organizer to have such a beautiful, 4 days workshop and 4 days of workshop and interacting with the industries as well as with the decision makers. For me and for my organization, I would say that this is a very good platform where we can showcase our instruments and the products. In fact, NPL is one of our biggest user of our instruments, and as we concluded our presentation with Dr. Mandal advice and Sir's advice with the black carbon analysis, we'll take this in forward. And also I would suggest and invite all the key members, all the decision members to have a visit to our Pithampur Indore factory, just to have a look that we really maintain a world-class facility, whatever facility, the manufacturing standards we are producing in Australia, it is the same standards we are also maintaining here in India also. And to be very proud on it that being an Indian, we say as a make in India that we are manufacturing the analyzers and instruments in India and we are supplying to the rest of the world. So I would request all the research fellows to at least have or interact with to us. How can we serve to the nation, to build up one nations and to fulfill the requirement of the CSIR labs as well.
Thanks, Mr. Roy, for such a nice and brief overview. And I would like to invite a representative from QA Technologies to tell us that how this Indian industry is facing this testing and calibration roadblocks, and what are the roadblocks testing laboratories are facing. So, and how NPL can also strengthen UP.
Good afternoon, all of you. Anil Tripathi from QA Testing Laboratory, a complete building material and road material testing laboratory. And we have the facilities, all the facilities and expert technical teams, and to analyze all the building materials. And we have 4 branches in India. Head office is in Noida, Sector 64, and now we just established a new branch in Solan, HP, and we are doing best services in the government organization like CPWD, NDMC, PWD, and many more other. And we have a vision to be the trusted partner for the quality assurance in the field of testing, and in the food quality assurance program, customers data meets as well as international quality standards. And we are following the software LIMS, Laboratory Information Management and System, which is a software system developed to support laboratories operations. And we have modern equipments and infrastructure. We are doing mechanical testing, chemical testing, non-destructive test, and geotechnical investigation. And in the industry of coal, coke and petroleums, we are doing the products in these industries. And many more, whatever we have the facilities, we have managed to test. And thanks for inviting us in NPL and Mr. Dr. Shankar Agrawal sir. Thank you, and thank you all the members. Thank you very much.
Okay, thank you, Mr. Tripathi. And now the session is open, so anybody can ask some relevant question to our panelists. And is there some students are there? Okay. Yes, Pankaj.
Yeah, good afternoon. This is not a question, this is just a suggestion, because we had this MSME industry meet with the NPL. So though I also part of NPL, and in one way or other I'm also part of the organizing committee. So this question is for me as well, or suggestion is for me as well, for the industries, according to that as well. Suppose I'm working in the photovoltaic area. So I didn't see any industrial partner or the industries which represented, which could represent the photovoltaic industry. So I think we should have planned in a way that there are so many internal technologies which we have showcased over here, but there are only few technologies which find their counterparts, the industry which are really interested in their technology. So I think when we were planning this, we should have also thought of that, okay, these are the technologies which we are going to showcase to the industries. So we should also invite some industries in working in that area, or making, or the industries which are really interested in these technologies. So that is the suggestion which I think.
So Mr. Rai can give some answer to this. I think so.
Sir, very well said. In fact, to be honest with you, sir, I am in this field for the more than last 27 years, and I have worked in several positions in several organizations, from a very big Fortune 500 companies, and today EcoM has to promote their products. So the first and very important thing in any multinational organization, what we see is first is the quality, right? Now, if I am promoting my product to suppose NPL, so there are so many things which I need certifications. So without certifications, we cannot promote any quality product in this country nowadays, especially when CPCB or any other MOF has come to the picture, and they have becoming more and more stringent. But the problem where comes out is from the user department. I'm not talking about NPL, I'm talking about in the industry user department. The knowledge is very limited to their field only. And when they ask for any kind of extraordinary thing to be put on, so they say that this is the government regulation, you need to meet on these government regulations. But they do not want to put on the effort what are those government regulations. For example, if NPL has come out with some labs, or NPL has come out with some regulations or some procedures, they will just throw, the industry will just throw these regulations or the procedures to us and to meet those procedures. But they will never try to find out what is the basis of these procedures and the regulations is. So the first thing as a user or as a trendsetter, it is our duty to educate the industry for the selection of the right instrument and for the right monitoring systems. And that is where we as an Indian is lacking behind it. And that's a very, very important part on that part. There are some industries, for example, if I talk about IOCLs, if I talk about NTPCs or mini Ratnas or Navaratna companies. They are trying to equip it, but still we are way behind of these technologies to adapt it. That's my submission to everyone in this hall to please try to understand the main course of these procedures and the guidelines. It is not just like the government has, it is something like you are imposing them to put this thing or implementing this thing in the industry. So it is my request to the industries that please try to understand what is the main course behind it, why these procedures and regulations are coming up for the industries. It is only for the betterment of the human, for the country and for the industries as well. Thank you very much.
Thanks, Mr. Roy. So now let me ask one question from the students are a little bit shy. You said that we should mean these students. So here in NPL, we provide them the research infrastructure, but the real problem, what we feel in the industry, we don't have any mechanism that these students can go there and work as a kind of intern for 6 months or a year, and out of those things, the industry can choose certain people, those who are having good training within that particular period. So we are missing that kind of mechanism in Indian industry.
Sir, EcoM is very much known for their services, not services. We give trainings, we adapt this kind of services. People who really wanted to highlight in their career in some XYZ field, please do come to us. We'll do some kind of arrangement so that it will be beneficial to you as well as to us.
Thanks. This is really required actually for the youngsters.
Right.
So any other question?
I am Saravanan from NPL. Sir, actually, whenever we are seeing startup MSME industry meet, the 18 to 20 or 70 to 21, then after that we all forget, either from government organization as NPL or industrial side of point of view. See, whenever we are talking, we are approaching to industry, only is one-way communication. It is an open loop communication. The same thing, some industrial person is approaching NPL. After that, some channel is going on. After that, then again open loop communication. So there is a mechanism should be provided. See, like our startup MSME industry meet, we are facing the same problem. Only the 5 days. After that, industrial people will forget, NPL people also will forget. So some mechanism should be there, either industry side or our NPL side. So some panel should be there, or some department or section should be there, or some scientist in charge will be there. They can answer from industrial side what happened, this interaction. Or not only this program, in any one industry people ask any question, any help, anything, some mechanism should be there. It should not be a open loop system. Always it should be a closed loop system. So such mechanism we want to implement, either industrial side or NPL side. From that I am giving this suggestion. If you are accepting or whatever to your opinion, how to implement, it will be good for us. Either NPL side or.
So I bring this question to Dr. Agrawal because it is more related to you for deciding all these things.
Yeah, actually this kind of meet, of course, as you said correctly, it's needed because we also need to know, what's the requirement of the industry side and what we are doing that should go to the industries, right? Number one. But of course, we should have a permanent office through which we may have this kind of communication. So interface is needed, and for this we have a, that we are from NPL, so we have a business development group, right? But of course we have a manpower issue. So, and also some, say website or some other communication needed. So definitely your point will be noted, and we will work on it as per our, panel discussion note. We will make it. So hopefully in the future we will have a more better communication with industry, and the same in the reverse side, that industry can approach us or we can approach to the industry, right? So we will see. And I just want to tell the answer of the Dr. Pankaj that of course, we have many fields, and we send the letters to many industries. But industry, I got a lot of reply from them that, sir, of course you can put the install there, but the audience would be only NPL scientists or students, right? As we have written in our brochures. So I think, and then also when they came here, they also said, sir, it's not, because they also need to have some business or advertisement. So they want that we should also open our NPL activity, what we are doing, the services for the industry, like testing, calibration, and research. So they can go and see, and accordingly, like we do for the students, so we can also do for the industry people, right? So they can closely interact with the scientists. So next time probably we can have this one step, that we can also open this activities, our services, just to look at for the industry people, so they can directly interact with our scientists. So this is one point we also noted, in this meet. So we are improving, of course.
Thank you, Dr. Agrawal. And to the question of Dr. Saravanan, actually, sorry I was not there for last 2 days. Initially, myself and our team, we have discussed one thing, that we will gonna make a minute of meeting of this particular event, and we're gonna circulate it to the MSME, and we're gonna have this in the office of our BDG group, so that based on certain points, some action could be taken. In that way, we can keep this industry and NPL connection live, right? So this is what we're gonna do after this particular meeting, and all these suggestions will gonna be incorporated there in the minutes of the meeting.
There is no feedback, or there is no even a single reply came from industry. Same thing here also, industry people approach, same thing happens. So some mechanism should be there.
This is what we are trying to develop. This is what we are trying to develop after this particular event.
Good afternoon. I would like to add on this thing that I will appreciate NPL that this is the first time we have taken this kind of the decisions for the startup and the MSME meet. And I think the industry should also appreciate the thing that they have got the space and the time to showcase their technologies and the whatever the interaction they have in the past with the NPL and things that to showcase the public. So they should also, I think they can appreciate the things that that without investing even a single penny, they have got the good that kind of the platform to showcase their things. So that's what I wanted to add. I think that this the feedback from the industries, whatever we are getting, in the future we can accelerate more things in addition to this kind of the meets. That's all.
Thanks. So, any comment, Dr. Agrawal, for this?
Yeah, we must say thanks to the industry that they came here, and of course, it's mutual cooperation. So the same thing, same way we also look forward in the future. And I just remember now Mr. Ranjit's comment, like he said, for the training, right? So manpower, of course, both important, like quality testing and then the manpower. In the morning, today morning also in the session, many many speakers said that in India, when we go for the Make in India program, when we develop the product, product testing is an issue. So without testing or certification, nobody wants to take it because the confidence is not there, right? So because this is the mandate of NPL, so NPL can do this, and in future we have also noted this point. So we will try to enlarge our capacity for testing and certification and all kind of, because NPL is a very small body, it cannot do, but in the support of many other testing laboratories and other organizations, we can do it. So probably this point also we will note down, and then we can we can send your voice to our authorities. Definitely we will do it. Yeah. And then the training point, like as we are from the air quality monitoring, so when you develop any air quality monitoring instrument, the important, once you sell it, of course you can sell it, but the maintaining of this instrument is very challenging. And I saw many crores of rupees invested by the government, but after 1 year, it's not working, the instrument, because we don't have the trained manpower. So NPL is also open, and like you are now, open your manufacturing unit here, so we can work together, because we have students, and we can send we can teach them the science, we can teach them the technologies, but you have a lab, right? So they can realize the practical knowledge in your lab, and once they train, we can jointly issue their certificates that they are the trained person, and the industry can hire them. So this is one way we can go, and probably we can look at on this issue, and next meeting, or with our authority, we can do it. Yeah. Thank you very much. Yeah.
Add on your sir request, I would also have a suggestion, like if you can just set up our calendars, maybe in every quarter, if you can have 2-3 days interaction with our real technicians or the people who are in the field, so that at least they can teach you, or they can calibrate you the troubleshooting part. For example, if you are using an AQMS, or you can call the other users as well. So it will be a knowledge gaining kind of thing also, and you can understand the new technology which is coming in this world. So that way also we can, obviously you can always send your person to our factory and you can have a hands-on. But before that also you can set a calendar for each industry. I'm not talking about just air quality. For each and every industry, if you can just set a calendar for 1 day or 1.5 day for a training kind of thing or troubleshooting kind of thing, I think that can also enhance the productivity of NPL as well as for the industries as well.
Definitely, this is what is required. And actually why I brought up this particular issue, when I was in the US, most of our students, in summer, for 3 months or for 2 months, they used to go to different industries. And by the time they were finishing their degrees, they're going to have job offer from there. Because now the employer know their capability, they know what they need to do in there, right? In that way, but the day they start doing, they are more productive. But in India, scenario is different. You have, you just recruit your candidate, and for a year you are giving training to them. And after that, they are coming up with the full swing. So actually this gap we need to, this is beneficial both for industry and NMI as well as for the youngsters, right? So now with this, if there is no question, do we have another question from the student side? No. So then I request Dr. Bhanu to summarize this, right? And then I will get put up.
First, before summarizing, I just slightly add to the answer of the Dr. Pankaj question. He was asking how many industry or related to the why the photovoltaic industry is not here, whatever the work has been done. For example, you see, we are having 7 installed, okay, for different technology. One of the technology which has been developed for the polystyrene film for calibration of FTIR, I think the C-round scientific solution, the Mr. Raghuveer Reddy, he was present here yesterday, and he took the technology from the NPL of the Dr. Ashish Patra and his team. It's a very important technique. Okay, so and another, I think PM10 sampler technology which has been given by, if am I right? Yeah, that's an environment solution. That's also available. So, but up to certain level, it's good that some of the product or technology which NPL has developed has already been, the industry was available. Yeah, these are new technologies which other department has also developed, this photovoltaics, as you're saying, the printable photovoltaics, some carbon-based product, and just we also discuss previous lecture, right? Another some kind of a program will be there, so more industry will come here. So that can be added further. So this is, and finally we see that was a 3-day program, and MSME is starting from the inaugural session, very good. And the director or CMD from the CEL, they gave a very good inaugural talk and said this is the part of the NPL, the small activity, the ferrite based activity has been changed to a new lab. Then the one person from the Niti Aayog, Dr. Ashok, they also discussed different kind of policies that can help the industries and also the academic institute and our laboratory type of institute. So that can fulfill the requirement of a society, the further improvement in the either in the form of a startup, MSME in the industry. Then the industry that was from the Tata, Mr. Goha, that was a very excellent talk given by the Tata. He was talking about how the NPL has suffered, some kind of they was having some issue related to the pitch. So they have come out with some kind of a solution that can improve into their plant. Then BND development, there Mr. Saha, they explained very well about that new BNDs are coming with the collaboration with the NPL. So these were in the talks which were in the inauguration session. After that, we have this session, open session, in which these our install, and then a lot of people, I think more than 100 people every day are coming on the stall. Our scientists are explaining, the students are explaining in a very nice way. So that will help in the near future to interact with the industry, and that some of the technology which is very well pipeline or the developed, they can be transferred to the industry. And after that, we are seeing the different lecture from the expert of the industry or our scientists. In these 3 days, it was very, very interesting discussion. And finally, now we are concluding this session with this panel discussion. So thank you very much. And now I would like to,
Thanks.
yeah.
I would like to thank all our panelists and for their valuable inputs and answer to our queries raised by the audience. And definitely I would like to thank all the audience for their patience. And without them, even our program cannot be so successful. So thanks everyone.
Thank you. Thank you. So we close this MSME meet. Yeah. Thank you very much.
Now I will invite Dr. Parveen Saini to felicitate our guest, Mr. Anil Tripathi. From QA Technology, yeah.